For welcome address.
Dear participants here in this room and very far over web, and to start my welcome address, I just say that it's great honor and pleasure to greet you in our Academy and to congratulate the organizers of this seminar, because the topic is interesting, the topic is hot, and I wish you really good discussion. Our Academy is involved in development of science, innovation and technology in this country and even wider. And for this reason, we are really very much interested in situation in science, because we need educated people, we need educated scientists, and of course, we hope that this will support development of our Academy. Therefore, Academy has the deepest interest in development of science education, and of course, different other education branches also. And we have to say that we are witnessing different and very important changes in society, in technology, and all these changes affect somehow how do we teach our young generation in school. I am pretty old, and I witnessed a process when word became more connected via internet, and even before, when we witnessed appearance of computers, not only in laboratories and in workplaces, but also in schools. And this development changed quite a lot of education. And I was very happy because I was able to support or to organize this change somehow in Estonian schools, because some 20 years ago or so, we were able to introduce Estonian language teaching software in our educational establishment in schools over Estonia. This was at that time really high class and top software and top teaching tools, because we translated the software from educational packages which were produced by New Media in UK. And later developments revealed that this was really world-class software. We made it in Estonian, and as I can see my old friends from Finland, I can say that we also made this translation of different pieces of this software in Finnish and also in Swedish, but these pieces never reached Finnish and Swedish schools, and our friends from Finland and Sweden said that, okay, this is not very acceptable because this software is not translated by Swedish teachers and Finnish teachers. This demonstrates a little bit how complicated the situation was, but here I would like to say a few words as I have this microphone over my neck and I have this position here, just a few words about some other aspects. Introducing the software, we accompanied by massive education of teachers. We organized courses in Tartu University, and the number of teachers which attended was in hundreds. And we know that the software was really used in very, very many schools. But then, organizing these school courses, we observed that there are some areas in Estonia, counties, which are very highly interested in this software, and some other counties which are not so interested. At the same time, if we checked the marks of students in chemistry and also in biology and in physics, in these counties we could not see big difference. So the marks were almost similar. I am talking about marks of state exams. So, but then we discovered that the number of students who attended the state exam, let's say in biology, chemistry and physics, was really very, very different in different counties. And probably teachers and headmaster of school told that, okay, you are not good for exam in chemistry and in physics, so better take something else. And this statistics is very solid because this was officially published by our educational system, and we really observed that some counties have very small amount of students, some counties have high amount of students. And these differences were 2 times in biology, some 4 or 5 times in chemistry, and 10 times in physics. So, now the question can be asked, what's the difference in these counties? There can be different things, and I think that the most important thing is atmosphere which is in school. How the school is oriented towards science. And this data and this analysis was published in 2007. I don't think that there is a big difference even today. But in 2007 we were able to publish this regional heterogeneity of interest of students in different fields of science. And we were not publishing some other data we also collected. For example, it was quite clear that these regions where interest in science was high, in these regions the headmasters or directors were mostly or quite often science teachers. And this statistics can be also made quite clearly. In some other regions where the interest for science was not so high, the headmasters were not science teacher of physical education or teacher of drawing or so on. So now you understand my idea that the pie of education has very many layers. And the situation is very, very complex. And I wish you a lot of energy and wiseness to discuss the topics you are entitled to do in this seminar. And once more, best luck and have a good feeling and freedom to go until the end of the reasons which are covering our education system, because we all depend on the outcome of this. Thank you.
Thank you. Thank you, Professor Jaak Järv. And now I invite here Professor Jakob Kübarsepp, who is the head of the Educational Committee of Estonian Academy of Sciences. Please.
Thank you for introduction. My background is not at all social sciences. My background is engineering. In particular, materials engineering and such issues. But nevertheless, not only I as a professor of Tallinn University of Technology, but other professors are very interested what happens in schools. And in particular, we in Tallinn University of Technology are interested on the quality of science education in high schools, and so on and so on. I think that the topic of today's seminar, there are two important key words: science education and science-related careers. Both topics are of high importance, not only in Estonia, but in most of European countries, to my mind. Why I think that it is very important to discuss these issues. There are several problems in Estonia. I characterize very shortly only 4 problems related directly to this topic today. The first problem is attracting of students to STEM, science, technology, engineering, mathematics, education, related fields, curricula in Tallinn University of Technology and also in University of Tartu. This problem of attracting students is quite old. I remember the similar problems were already 25 years ago. But especially it's difficult to find students in engineering, manufacturing, construction, and natural sciences and mathematics. It is the first problem. It is directly related to other problem. It is science teacher training. Science teacher training, it is even more serious problem in our small country, Estonia. No, it is very difficult to find teachers in mathematics, physics, chemistry, biology, and so on. I remember when I was a dean of faculty or vice rector of Tallinn University of Technology, all the time, every year in the beginning of September, the same situation. Schools are asking, we need teachers in mathematics, in physics, in chemistry, and are Tallinn University of Technology able to give some teaching staff members to participate in teaching in schools. So it was quite a problem 25 years ago, but it is very not interesting. It is curious that it is even a problem now in year 2022. It is a second problem. So the third problem is attracting an Estonian citizen to the highest level of education. It is doctoral studies. Nothing similar happened 20 years ago, I remember. But now, one example only. In Tallinn University of Technology, in the field of IT, 40 PC students started this year, 40. From this 41 or 2 for citizens of Estonia, 1 or 2. And I remember only 2 weeks ago, there was celebrating of Tallinn University of Technology 104 years of Tallinn University of Technology, and also the diplomas of PhD. Diplomas were given to the student, and I remember there was about 77 PhD graduates. From them, Estonians were only about 30%. Not Estonians, but Estonian citizens. 70% not Estonian. And it is becoming worse and worse every year. And here I come to the fourth problem. It is what this demonstrates. It demonstrates that academic career is no more interesting for young people. It is increasing. I told with my colleague before this seminar, only 15 minutes ago, about the teaching in university. I am also already professor of emeritus. I am not very interested in teaching very much. I am making research in some projects, and starting from this semester was my plan to give some lectures to younger people. But it happens that in spring, 2 young people left university at all. It means that I should teach now their courses, not leave these courses to them. These are the 4 very serious problems directly related to today's seminar topics: science education and other such kind of issues related to that. And finally, I represent here, as already was said, Education Committee of Estonian Akadeemia of Sciences. Now, this committee is quite new. We launched this in spring this year. One meeting was in May, and the second meeting will be in October. And Mia is also participating in the work of this committee. And why this committee was launched? It was launched because Estonian Academy of Sciences is planned to be involved in issues related to shaping of national education policy. We have several problems here to be solved. And finally, I wish every success to this seminar. Enjoy not only the content of seminar, enjoy your stay in this nice building of Estonian Akadeemia of Sciences, enjoy your stay in Old Tallinn, and successful day for everybody. Thank you for your attention.
Thank you, Professor Kübarsepp, and once again, thank you, Professor Jaak Järv, and thank you for the family of Estonian Academy of Sciences giving us the opportunity to be in this beautiful building and collaborate with you. I give now a brief introduction to the program and a little bit to the background of the event that's happening here. So many of you have been here a year ago, exactly a year ago, when we had previous conference together with Akadeemia of Sciences, and that was about paradigm shift in science education. We had a number of worldwide famous people giving presentations. We had presentations from United States, Israel, Helsinki, also from Estonia. And we had also young scholars talking about their practices. But that was maybe too theoretical, because we didn't give people much of the time to discuss between each other. And now, for this today's International Expert Seminar, we decided to change a little bit the format, to bring all the points that we discussed closer to public, and give a little bit more time to discuss between each other. And furthermore, the difference between this event and previous event is that I could say that this format is a bit hybrid, because there are people who can actually watch what we're doing here online, in live. and they may also interact during the lunchtime, giving the questions if they wish to, so that we can actually address answers later on to them. So what is then today in the program? The main issue is that how to attract young people to science and science-related careers. So who can help there? Obviously, curriculum is a strong support for that. Obviously, teachers. Obviously, society. Obviously, scientists. And we brought here this time representatives from 3 different academies of sciences. And we also followed that not everybody is coming from the emeritus age. Also, some people are younger. So Hungarian Academy of Sciences is represented by Andreas Professor Patkos, and Finnish Academy of Sciences is actually represented by a young scholar who is doing a PhD. And Marianne, you will talk what's happening in Finland and later on. Then from the SciCar project, this event is part of the SciCar project event. Here is Professor Ron Plunder, and she's talking from the Israeli perspective about science-related careers, highlighting research and also what's happening amongst the teachers. And then we have 2 events where everybody can participate. The first event is in the morning before lunch, shared by Associate Professor Regina Sobart. This is discussion in discussion groups, and after the lunch, discussion groups get the floor to share their ideas. And right at the end of the day will be panel discussion chaired by Professor Jari Lavonen. And our panelists are coming from Hungary, from Israel, and from Estonia. And here 2 Estonian young people with high expertise in this topic are coming in. So one is in curriculum development and another is in teaching practices, both PhD holders in science education. And I hope and I wish that panel discussion will be very, very fruitful, and concluding remarks, which will be forwarded by Professor Jari Lavonen, will sum up what has been happening during the day. So now you can see slide in front of you. And this slide is not original, but it is also original. The originality comes from the division of the skills, how these are grouped. The skills itself are taken from the 2030 skills document. And this has been taken as a framework for sister project to SciCar, which started half a year later, which we called High Flyer. And we named High Flyer so that these are the skills that should be promoted among young people. And our target is to promote these skills among those who yet haven't decided to become a science teacher. So that students at bachelor level, even graduate students from the schools, they understand that, look, if we promote these skills, then we can fly high. We are science teachers, and science teachers' capacity, skills that science teachers acquire, these are so important that besides being successful and very good science teacher, you can work elsewhere. And which are these skills? So we group these skills this way. So starting from the thinking skills, this brings in importance from the science. So we can think, we must have strong science background. And this brings me to the dilemma what has been over the 10 years in Estonian education. When at the 2000s we started developments in education, then we thought that, oh, there is so much science content and too little skills development. But now the question is that, is the balance right, or has the balance disappeared away from science science knowledge. So science knowledge are important. So we need to value science for the life, so science for STEM. So without science knowledge, we can't talk about promoting, developing thinking skills. So everybody needs strong science knowledge, but not memorize, but use of those knowledge, be creative, use this knowledge in social affairs, so that the next one, what we are talking, are social skills, which are very, very important in all areas of the life, including science teacher. Then self-management skills, important. But again, we build that on background in science. Communication skills. Obviously, as Professor Jaak Järv already started, that Estonia made first steps in promoting ICT skills. This is communication. And now look how far Estonia has reached in this area. But still, we have way to go. And last but not least, research skills. So we wish that people are able to make justified decisions, not just talk without evidence. And from that, we are going to trustfulness, so to think about what is science, what is not science, pseudoscience. And there are also projects called Alive, where there is development of teaching learning materials to feed the school with equipped materials that students can discuss. Is that truth or is that not truth? And that is also, as a sister project, was a SciCar initiated half a year ago, so-called evidence. So evidence must be trustworthiness, and the leader of that project is sitting amongst you, and she's also talking this afternoon. So I finish here, and I don't want to push my slide, my division of the skills, because you might have come up with something more meaningful. You may think that maybe some of the skills are more important than others, but this is all the product of today. And may I now introduce the keynote speaker coming from Hungary. And as I said, science is important. Without science is no critical thinking. Correct? So I'm very happy to introduce Andreas Patkas from Hungary. He's a member of Akadeemia of Hungarian Sciences from the 2000s. So he's a physicist. He's not educationalist, but he likes education. So he has made huge steps towards education, bring together educationalists and physicists. So he is a person who can value the educational component in society and at the same time also put together with developments in science. And being 2 decades a chairman of Hungarian Physics Society, he knows exactly what that means. So, Professor Patkas, the floor is for you.
Okay. Dear Charlie, dear colleagues, it is really a great honor for me and also for my colleagues who have participated in this project initiated by the Hungarian Academy of Sciences, that I can present here some of its aspects and in an intermittent way, since it is not exactly the topics of your seminar, but I still try to get contact to the main question already raised in the introductory remarks. So let me start, and tell me if you are interested, but you cannot read something, because I will make jumps since the material is much more voluminous than the time I have. So let me start with our legacy, which is a very Hungarian legacy, and whatever modernization comes, you should respect the legacy, and you should somehow build on it. It should be different in other countries. So Roland Eötvös is a world-famous physicist because of his experimental achievements in gravitation at the end of the 19th century. Only in Hungary we are conscious that how influential he was in forming, in shaping Hungarian schooling system. And here you can read some of his propositions, which he started to make very early. At age 26 already, he suggested to found a teacher training college following the example of the École Normale Supérieure, which later on, with end of fights of 20 years, he could also realize. But he is the founding father of the Mathematical and Physical Society, which started mainly or essentially as a society of mathematics and physics teachers. Separate journal was launched already at that time for high school students, for nurturing talents. So I believe that the pupils of Eötvös, the young and the elder Eötvös, and there is the father, the portrait of the father of Eötvös, who was a minister of cults and education. So his commitment has a family root. So the pupils of Eötvös were really dominating the Hungarian education customs till the mid-20th centuries, at least for 100 years. So Eötvös had very strong views. He said that what is important is the teacher, not the schooling system. The schooling system is something on the second plan, but the teacher's personality and teachers, in case of teachers, he was favoring scientific preparedness, the knowledge of the discipline. He wrote as an entrance address when the first issue of this mathematical physical journal has appeared that we want to present the latest results of the world science pedagogically, that every teacher could follow and make use of it in the teaching procedure. In his inaugural speech, rector's speech at the Budapest University, he expressly told that we have to train teachers to scientists. I won't continue, maybe you will read it when I leave here the slides. So I just want to give you one example of an outstanding teacher coming and following the Eötvös school. His name is László Rácz. László Rácz Prize is the highest valued teacher's recognition which teachers of science, biology, chemistry, physics, and mathematics can receive in Hungary for their whole lifelong pedagogical earth. László Rácz was a math teacher, a headmaster of one high-level secondary school in Budapest, editor of the high school mathematical and physics journal devoted to talent nurturing, but he is memorable in the Hungarian public, very widely in the Hungarian public, by discovering and mentoring two very famous persons who have their name in the history of science, namely Eugene, Jenő in Hungarian, Wigner, and John von Neumann, János Neumann. I did not give next in parentheses the achievement of Wigner in nuclear physics, neither the beautiful theorems in functional analysis by Neumann, but something which came out from their oeuvre, from their activity, often quoted by the community even today. Wigner often called to be the first nuclear engineer. And the von Neumann architecture of computers was until recently the exclusive way of building the computers. So my first intermittent message to this audience is that we have to teach our students, the teachers have to have nice examples that actually the scientists have an exclusive chance. They might found new industries which do not exist before they started. They grew out from fundamental activities, from fundamental achievements. Unfortunately, Eötvös' original concept about teacher science is not sustainable. The complexity of the scientific of the science itself puts an obstacle to satisfy the wish of Eötvös to present the latest results of the world science pedagogically, what every teacher could follow. It's impossible more. At the end, and towards the end of the last century, actually academicians, high-level scientists made a big effort, put a big effort to pack into the curriculum of different science subjects the whole new achievements of the 20th century on the top of the story started with Galilei and Newton and so on. And it became a complete disaster. It was undigestible. Everyone, teachers, students became really frustrated. And this was a reason the teachers in Hungary, at least, could resist very successfully against these reforms. And this led somehow turning away from science. At least this is my personal experience. I was already a young assistant at that time. I could witness the efforts of my professors in this sense, which resulted really in a horrible dispute and some sort of conflicts. And turning away from science leads, unfortunately, to pseudoscience. And the edge between science and pseudoscience is something very, very sensitive thing. This is my intermittent second message to you, that you should be very careful when you try to attract the interest of your students by presenting the latest results in a colorful, schematic, nice way. These two pictures come from the official website of James Webb Space Telescope. But you should not teach it except if you teach also how they are synthesized. Such pictures were never made by James Webb Telescope, because James Webb Telescope, as probably many of you knows, observes the universe in infrared, not visible for our eyes. There is a sort of transformation, and one should be honest. And in this sense, I am very strict and following the statement of Eötvös back again, that you should not transform physics teachers or science teachers into magicians. So, what we should do? We should try to go over to a much more contemporary approach of understanding science teaching. And since I am not an expert in educational sciences, I quote a Nobel Prize winner, in physics who clearly recognized that understanding the success and failure of teaching and learning physics, or in general science, is similarly complicated, requires many transmissions, many steps of mediations, as it was the case of quantum physics. There are no direct ways to touch the electron. There is no direct ways to understand how a student is thinking about the physics exercise he has to solve in the afternoon. So one has, as this quotation from Wyman tells us, we have really to start to study similar to as we did in case of the atomic structures, collect data about how people learn, how students do or don't learn various topics. And this is equally difficult, equally complicated. It is a scientific activity of equal value as the atomic physics or any other direction of scientific research. I also quote here, put here a Hungarian educational scientist who emphasized the importance of pedagogical experiments conducted along the same principle of scientific thinking, but also added that it should be under the control of the teachers' community. You should cooperate very strongly with the teachers if you wish to get somewhere. And this is the way we started, following this guidance, which I just tried to quote fragmentary in the previous two slides. This was in our mind when we launched the content pedagogy research program of the Hungarian Academy of Sciences in 2016. The key directions, I would not list all of them, but just I call your attention to the second row about the renewal of Hungarian teaching traditions. So we should not negate the Eötvös legacy. We should find out how we can build it into the new approach. And in red, I put which is my favorite point, that we accepted applications only if there was a substantial participation, not just one or two teachers, but there was a substantial participation of practicing teachers. And in the required work plan, which we gave the main lines along which it should be composed, we were also telling that already at the very beginning of a 4-year-long activity, they should contact those educational kindergarten and primary schools and secondary schools, those educational institutions where they will test the evidences for the failure or success of their initiatives. What are the facts about? So we received quite a number of applications, and 19 of them we thought that could be supported. I have to admit, although I am not an expert, but they were real educational research experts in the jury, and they told me that no more than 3 of the teams were already conscious and with earlier activities following what internationally is thought to be a pedagogical project, pedagogical research project. But we wanted to help the development, and in this sense, we gave a sort of credit to the other groups which hold the which have held the promise of developing during these 4 years into a real educational research project and group. So from the 19, as you can read in the STEM classification, we counted 10 groups, and also, which is written in red, the number of active teachers grew during these 4 years quite constantly, and at the end it has reached 40% of the whole staff. And just following the idea, or relating to one of the 4 questions raised by the president of your educational committee, we had 70 PhD students who were working on their thesis within educational research, which holds some sort of promise for the younger generation joining this sort of research. The program was run very autonomically. So we got with this program council complete free hands to run, to manage that modest, but for Hungarian standards, quite substantial amount of budget, which the Academy of Sciences from its own budget, not something extra from the state, but from its own budget appropriated for us. And with a yearly report, we always presented a sort of progress reports to the General Assembly of the Akadeemia of Sciences. The yearly reports of each group were evaluated by Hungarian experts. It is not in Hungary. It is not easy to find 38 experts who accept to work through the reports, but we somehow managed because there are not too many educational experts. Most of the or assessors came from disciplinary science. But we were very happy to have an international board of friendly critics. And when I prepared myself, I went through the list of these friendly critics, and I found that very spontaneously, 10 of the 10, out of the 10, 3 came from Finland. And we were definitely enjoying very much. Actually, they came from very different directions. Jari Lavonen was responsible, took the responsibility working with science, but Kallio Tavin about visual culture, and Ritva Takkinen about the pedagogy of the children with special needs helped, which are well developed. So at the end, the Academy expressed its recognition to the most active teachers. In the middle of the pandemic, we managed to organize a session, a celebration of those 56 active teachers who received honorary diploma from the president of the Academy, which was something very, I understood that it was appreciated by the teachers very much, and it strengthens the contacts between teachers, schools, and the Academy. Here you see the list of the qualitative progresses. I emphasize only the last, because this is, at least to my subjective judgment, is the most important, that a new perspective has opened for active teachers, for scientific, real research collaboration with academia. But also it is important that the isolated groups, through this research council we were working with, started to self-organize themselves into a community. So what I would like as a third message, if you wish, to transmit to you, that through this personal experience of teachers in participating in a real scientific activity, which is as difficult as quantum chemistry, quantum computers, educational research, they get a sort of self-confidence, and in this way they much more authentically present science subjects to their students, because their personality is a guarantee for the scientific value of what they are teaching. There are also other channels. The Academy of Sciences tries to get closer to the schools, to the students and to the teachers. Here I just give two examples. So I would not say that our program is an exclusive, has an exclusive role. I think the Academy of Sciences makes quite a strong effort. So now I would like to shortly give you some sample results. Here about science education. Just I point to what is written in red. There were three groups, two about physics and chemistry, the other about general scientific reasoning, trying to put into the content of each of different subjects the exercises which develop, which give a general background for scientific reasoning, for developing the scientific reasoning of students. But what is important is the number of the participating active teachers. It is important the number of physics teachers who during these 4 years have obtained a PhD degree. It is the number of physics teachers who gave either oral or poster presentation, even they led workshops at this World Conference organized by GIREP in 2019 in Budapest. There were 27 active teachers who were able to present scientific papers of different quality. I would not say that each of them belonged to the forefront of educational research, but they understood what does it mean to present a scientific result, and that gives them quite important experience. Similar thing happened in the chemistry group, where for 4 years the 32 teachers were working together at the end taking over many of the duties which were started by the researchers themselves. For example, the worksheet designs and other important parts they could do themselves. They learned it. Here I wish a little bit stop at the technical informatics methodology. They started by just a technical development. They built a very cute interface between sensor and computer, which is very universal, that you can do with it quantitative physics, chemistry, or biology measurements, and they stopped at this moment. And then 5 teachers joined them, and suddenly they worked out a complete introductory high school physics measurement series. And you see that through the website of this group, they started to advertise an in-service course, which went, I heard that here several hundred teachers went through this further education in how to use informatics. Now, just spontaneously, more than 2,000 people, teachers, started to use it, started to learn it. Even more, students visited quite frequently the website of this group, where consultation was and still is available for anyone interested. And they went and convinced their physics teachers in the middle. And they decided to learn this Arduino-based methodology together. So with your eyes, maybe you can figure out those 2 items, which really an intrinsic student project was realized after where they somehow checked what they learned. To this class, I would also classify the new initiative for writing a new style geography book, if you wish, or separate sheets, which is a new approach, problem-based complex presentation from physical geography to cultural and touristic institutions. And this new geography book, which is not an obligatory material, contains actually quite a number of QR codes. Here you see one page with my very bad quality photos, where there are, I don't know, I did not count it, how many QR codes, where students have the freedom to continue, to have a deeper knowledge, and teachers are encouraging students coming back and telling them what they would like to make as research, essentially when it is about their own living neighborhood, then they have very interesting and innovative ideas. And again, the next message is that somehow teachers should be taught to and should be socialized already at universities to be open to the initiatives of the students, to be prepared to learn together something which certainly the university curriculum could not contain, because it happens after they leave university. Nobody is working together with the students, being susceptible to work together with them by their proposition might be an important tool to increase the attractiveness of science careers. No, my time is good. It's written here that I have 19 minutes. I don't want to go against, but I just want still show you something which is somehow a third chapter, a third group of the results we obtained with our program. Because I want to show you something which is the way people try to renew the legacy of László Rácz, of the famous mathematics teacher. The tradition of Rácz was continued without any break in this past decades, because the very successful Hungarian team at the International Mathematics Olympiad were participating in the so-called Pósa camps. Pósa is the name of the present personification of the Rácz legacy. But this is not enough. This is not sufficient. So this group of discovery learning mathematics decided to introduce similar methods, finding out whether it can be extended, its applicability can be extended to the less gifted, to the normal students. And in a larger size letters you can read their initiative I like the most, the best, the flying school. During 3 years before the pandemic started, they visited more than 100 schools, selected exclusively in those poor regions of Hungary, where they offered an afternoon where this discovery learning method of mathematics on very simple, very low difficulty problems were presented. And they were watching the activity of the participating students and selected those who were the most active and invited them to regional talent nurturing programs where monthly, for 1 day, they were getting together not too far from their village. And an interesting outcome came. We were expecting that the esteem, the academic esteem of those who are doing this sort of research will increase by making it known to the wider academic public. And as an interesting result, let me call your attention that the first department of education in the Hungarian research system was open after we finished this program in last year. Its head is a mathematics teacher, but also working at the world-famous Renyi Mathematical Institute, which is, at least in combinatorics, is considered to be probably they say that they are the first, but let me say it, maybe among the 3 best. So they now have a separate department of mathematics education, and just as a result of this activity, the head was selected as the earlier leader of this research group. Similar thing happens in completely different subjects. For example, foreign language teaching was for digital new methods of foreign language teaching was worked out by a group, but if you understand this map, you can see that it was directed to mainly Roma-populated schools with very low social status, directly next to the Romanian border. So it is not the so-called the wealthy or medium level, but really the low level of social status was chosen. And it turned out that without the teachers, they even could not talk to these to this student population. And the teachers, after a sort of preparation, gave fantastic conference talks. They were giving valuable contribution to the teacher's background. The last one, here is a picture about how they worked. There is a third group of underprivileged. These are the children of special needs. And we had an autism in education research with the main goal to find new ways of including the high-performing autistic children into the, if you wish, mainstream classes. They initiated an intervention program. They, at the end, produced accredited teacher for their education. But what I want to emphasize here, that they very closely collaborated with organizations of the concerned parents, of the concerned part of the public. That was a guarantee, a way how to succeed. School is, in this case, not enough. Mainstream, the parents of mainstream children, and also the families who have autistic children should be included into this whole intervention program. It's a fantastic and huge task, which they just, during these 4 years, they started. So what is the lesson from these 3 groups? I believe we heard actually also that from the introductory remarks that there is a huge shortage in well-educated, in this case, informaticians, but also in other professions. And the only way is to, or at least the one very important channel where you can expand somehow the population, the educated population, if you directly try to find contact to the groups of low social status, explaining and proving that elevation of their social status goes maybe not the most, but almost the most directly through science-related professions. That in Hungary is extremely important because from the towns, including my granddaughter, children go somewhere to England or to Germany, but to increase the number of people who can do, who can work in high-tech industries, we have really to achieve something with those groups which are living at the moment on the periphery of the society. Yes. I am here in Estonia. I just want to flash that we also had a group working on the modernization of the world-famous Kodály method, which probably here in the country of the course and of the conductor family, Järvi, you might also know quite well. It's interesting. It was a very colorful and important initiative, which fortunately enough continues. So my last slide is just to show you that we have now already closed calls, evaluated calls as a result of this 27 new groups started their work last year, some of them only this year, and budget was increased by the president of the Akadeemia of Sciences, again coming exclusively from the Akademy's budget, this does not rely on other sources. And I just finished by telling you that now the chairman of the program council is not an amateur of these activities, a real educational research professional, Professor Benő Csapó, and I hope that you will be able to invite him at a later occasion and have a discussion with him, really using the terminology and interesting and concentrating on the interesting points of the educational research. Thank you.
So thank you. And now it's time to ask questions from Professor Patkos. And actually try to be the first one.
Pardon?
I will be the first one who will ask.
Then I have to follow
Yes,
you.
yes. So thank you for a very nice overview. And based on what you are talking here, it seems that things are in Hungary going very well. And young people are really, really interested in science and science-related careers. Is that true?
No. The whole activity, first of all, you see that the program went far beyond what we understand as science. So humanistics and arts were included. But the idea was to raise the interest in school of the people, of the children, of the young generation in general. Because apparently nowadays many of them, and not the least talented, but also talented children, feel that the school is some rigid environment where they are forced to go and they don't learn too much. And what our goal was with these projects, which we tried to push towards, to make more enjoyable without losing the professional level standards. We don't want to give up the standards, but we have a different approach where we take into account more the social environment, the psychological environment, the cognitive conditions, and I think it was more useful for those who participated, for the researchers and teachers who participated, and hopefully it will somehow become more and more useful also for the children.
So thank you. Rachel?
Thank you for a very thorough and profound, review of the educational projects. And I would like to ask, do the teachers who participate in these projects or come to the activities, are they rewarded in a way? I know that the best reward is that they get better, but for them, do they get some points which can, raise their salaries or something? It's a very tricky question, but...
No, it's an important question. I have a very definite opinion about Hungarian educational policy, but I don't want to tell it. What I emphasize was that our program was allowed to work very autonomously. So therefore, no one made any counter propaganda on or sort of pressure. They did not put on pressure on the teachers. Occasionally, regionally, they could collaborate quite well with the local educational authorities, public education authorities. But I, as a coordinator, collected. In Hungary, there is a lifelong career sketch proposed for teachers. From the class 1, they can, with an exam, go into the class 2, which will increase their salary. And then there are the uppermost two directions. You can become a teacher scientist, actually they called it, but I believe it is not what I was telling about, it's something different. And you can be a master, a teacher master, and then you really have a higher salary. So what I asked the group leaders in their closing report after 4 years, to tell me about the progress on this ladder of the participating teachers. I did not bring here the numbers, but the numbers were quite positive. So the teacher, him or herself, should initiate this sort of examination. An application should be submitted. And quite a number of the participating 300-something teachers got the courage to prepare an application, and quite a number, like say 50, 70, actually were successful. So this is an indirect way, because this program was not officialized. So, but even it was not any obstacle. I did not encounter any explicit obstacle. The only trouble was that we thought that some of the groups could continue under the umbrella of the governmental development plans. And there was no reaction to that, unfortunately, yet. Yeah, okay, I don't complain, because by the continuation of the Academy of Sciences, the new president of the Academy of Sciences, most of the groups can continue, and in this way the whole initiative is not losing, I hope, its incentive force.
Any more questions? Ülle, please.
Thanks for your presentation, very interesting. And you told about the non-privileged schools and students and the need to engage them more. Can you characterize such schools and students? Why they are non-privileged? Do they have non-standard learning programs, or don't they have enough good teachers, or why? Because it's in every country. And what can be done to engage more the students from those schools?
So, underprivileged schools, first, what I was quoting, are in regions or districts where, in general, families with very low social status, very low income are living. That can happen in Budapest, in some districts of Budapest, where exclusively or almost exclusively Roma families are living. And it happens at the edges of the countries, not only in the Romanian direction, but also towards Croatia or Serbia sometimes. So there, actually, the population has no jobs. So somehow the income of the family independently of their belonging to any minority. Everybody is unemployed, or very high is the unemployment rate. And this determines somehow how regularly they send their children to the school. Those tablets which appeared on one photo, I asked the leader of the group whether you gave the students. No, we could not do that because the family would take away and sell it. So after every exercise, they asked back the tablets and again gave. So only at school they were actually working with the tablets and learning the English, but this was also still quite successful. Now about the quality of the teachers. So since there is a shortage of teachers in general, even the highest quality gymnasium, high schools are complaining about losing science teachers mainly. So you can imagine that how usually physics is taught by, I don't know, music teacher, or so definitely science in many places in these underprivileged schools are taught by teachers who have no real education in their subject. So it's an extremely difficult thing, and this was the reason why I was so happy to get into personal contact with those English teachers at the Romanian border who turned out perfect, like being able to give a perfect lecture about their method when a meeting of Hungarian educational researchers was convened, and these ladies gave a beautiful account of. They are very conscious. So in this sense, I am still optimistic, because if they have the possibility for doing really higher quality intellectual work, this challenge might induce higher quality of activity on their side. This what Eötvös called that the everyday disillusioning practice leads to some sort of disinterest. This should somehow be prevented, and very, very partially only, but our program locally could somehow counteract of this disillusionment.
So thank you, and seems that last question comes from Priit Reiska.
Yes.
We should follow the time.
Thank you very much for this very nice presentation. It seems to be a very promising way to get teachers and researchers cooperated, to get also more teachers to do research, and it might be that it also helps to solve many problems, maybe raise quality of education at schools, but also maybe also to get more students interested in scientific career. But I assume that in relation to the whole country, it was a very small amount of schools, teachers, and also researchers which were involved. Do you think that in your example, it might be worth to say the ministry that maybe it should be do the same in large scale? And what do you think, is it possible to do that? Thank you.
Okay. I agree with you 100% that we were able to work together with a really small minority of the teaching staff. It is not true in case of the researchers. because unfortunately the Hungarian community of educational research experts is very small. Actually, with our activity, we more or less, you should ask Professor Chapo, but he told me that at least we doubled those who are involved actively, which already can be seen in the publications, which I was not stressing too much because I am more interested in this practical applicability. However, it's very difficult to understand. So we not only in the socialism or so-called socialism, but also since then, we were having several reformulation of curriculum forced from above, and never could notice any real progress. So this leads me, myself, very personal, to believe that somehow there should be something, we should find a mechanism to use the teachers' community, the researchers' community, the headmasters, to allow people to try to experiment. And the best, I believe, of the achievements I was showing you very quickly, when after 4 years, I asked the group leader, and he showed me the number of downloads. Because the downloads, if you have 2,000 downloads, that probably half of them is using really. But even 1,000 physics or informatics teachers using this Arduino-based project is already not a minority, because some 3,000 schools we have, or something like that. Maybe I am wrong, but not the order of magnitude. So it's very interesting how this diffusion, like dissemination, goes. Yesterday I told colleagues, no, I tell it in public. Teachers don't read educational research journals. They read those websites and which are actively maintained, where if they have a question, they can turn and they get a response. And in this case, unfortunately, the very last one, this Kodai method, Renewal, because of the pandemic, suddenly this database, this electronic database of songs and rhythmic exercises and so on, has been immensely used, not only in Hungary. 23 countries, they have this Google statistic. From 23 countries, download happened. They were asked to prepare an English version, certainly with English rhymes and songs, not Hungarians. They have a Chinese PhD student whose PhD thesis will be along working on the Chinese version. For me, maybe it is very slow, but I am a little bit skeptic about making fast progress. The Kodai method, for example, until it reached its height, took several decades of work of Kodai himself. So I just hope that the international collaboration, maybe this is my last word, so the dissemination should not be restricted to Hungary. I think it is very important that these groups should try to enter the new course, the projects in the new course of the European Union, and try to get known by their foreign colleagues what they have invented, and maybe together already they can more efficiently disseminate their achievements. But you are fully right. Okay, I don't know. There is an early bird in Hungary which appears at the beginning of the spring. A single such bird, which I don't know, unfortunately, the English name, does not make spring. So we need really a large number of people attracted to the participation. But thank you very much for your apparently vivid interest.
And thank you for answering the question. And we meet with you in the afternoon in the panel. Then you can speak more. And now may I invite Associate Professor Regina Soobart to make introduction to the discussion groups. And to those who are online, in live, after introduction, we stop and we meet with you after lunch, 1:15, to disseminate group work outcomes. So Regina, please.
Yes, hello from my side also. And like Mia said at the beginning, that this year we tried to include our audience more often than just putting them in the listener format. And that's why we are having now this small, but I think very fruitful discussion session. I will first introduce the purpose of this session. I will give you the 4 topics around which you can form groups, and you will have enough time to discuss in the groups what could be the answers for the proposed questions that I will give you for each group. And in the very end, I will explain how exactly we are forming the groups. Okay, so it might be like interesting question why we are having this kind of discussion session maybe quite early in the seminar and not in the end of the day. But the idea is that we would really like to activate you as the listeners for upcoming presentation. As you can see from the slides, more or less all those group discussion topics are around the topics which will be presented later in the afternoon by the scientists who have done really research work around these topics. But for you, this is the point where you can actually activate your own thinking around the same topics, and then actually the presenters who will give their speech afternoon can pick up some of the ideas that you hold in your group. And maybe they can give you some answer based on their research, so they will quickly know where to focus more and which are the aspects that people here in the audience are already knowing. And one very last group discussion topic is actually one of the goals from the SciCar project in general, how to attract the undergraduates to take the research in science education in a very high level, in a PhD study level, and later on becoming a scientist in this area. So I will now introduce the questions. So the first group will get this kind of topic. How should the school's education prepare students for dealing with challenging issues which might not even know at the moment? So all this goes along maybe with this climate change mitigation presentation in the afternoon, so you can already start the discussion or propose ideas, what can schools actually do, and then later on, when you hear the presentation, you are already more or less in the same picture with the presenter. And please don't take just this climate change mitigation. I have here said issues not even known at the moment. So how can we prepare students dealing with something that might happen in the next 20 years, but we don't know what this is, or happens next 5 years? So this is for the group 1. For the group 2, this is around students' motivation and what can we do in science classes to raise students' motivation and why we should do this. Because this has always been a topic around many years, and we are still talking about this. There is something which is undiscovered. So maybe when you talk with your peers in a group, maybe you will come up with some, I don't know, hidden ideas which are not presented to the audience before, and then later on can maybe pick up something for her presentation here. For the group 3, this is like maybe the most SciCar topic. Essential competencies needed in science-related careers. Again, we all know something, and we might think that this is like a trivial, but when we haven't said it to the others, then others might not know. Again, let's discover those hidden ideas, hidden competencies that maybe in the first place we don't think that are related or needed in science-related careers. Again, for you, a perfect place to share your ideas and learn from other experiences. And this is the last one. What can universities do to attract undergraduates to take research in education? And here again, please don't just focus on should they provide some kind of special courses, trainings, or so on, but think also from the university staff perspective. Which kind of support might those people need who are preparing future scientists in educational fields? However, they might not know at the moment that they are doing this because person can decide later, maybe after master thesis, that he or she wants to do some kind of research in science education. So I will leave those 4 topics in front of you, and I will very shortly explain how we will form the groups. But first, I have one message for the people who are watching us live, and then Mia as another one. The first message from me is that also we are doing our group work here, but please think also along with those questions. Find the one that is most attractive to you, and later on, you can also hear what our groups think about this kind of topic, because later in after lunch, we have organized the work in a way that you will choose, maybe during the lunchtime, one presenter from your group, and this presenter comes here in front of the audience, and there's a really possibility to speak the whole audience about the ideas, what they have discussed or what they have discovered or what they have found the most important. So those of you who are at home or office or doing something else and not being here at the moment, please think along. You have also a possibility to listen what others have said here in this room. And now Mia can tell other message.
I ask now everybody who is online to have a lunch break, and we meet 1:15. But those who are here, please stay, and Regina will share ideas how to divide the groups. So thank you.
Yes.
Hello, I hope we are now in live again, and I hope that everybody had a fruitful lunch, and those who are not with us have been thinking about questions that Regina put forward, so that everybody has its own viewpoint, what to protect, where to get support. And now I give across to Regina to chair the session, please.
Hello once again. And now the idea for the next 30 minutes is that the presenter from each of the 4 groups will come here and just tell around maybe 5 to 6 minutes what were the main discussion points in your group, or do you have any suggestions you would like to give around those topics. And we will go in a way that we will start with the first group, and I will give the microphone. So, from the first group, who would like to make a short conclusion? Okay. And introduce yourself. Yes.
Hi, I am Ulle. My education is physics and PhD in environmental physics. So I have long time worked in the university, and then in the ministry, and then and by now I am working for the Youth Academy of Tartu University. So we are proposing for school classes such experimental work in the University of Tartu. But I would thank my colleagues from the group first, so for trusting me to make the summary. So how can school prepare students to meet unknown? As first, we have discussed that it's required to give to students strong confidence about the environment around us, and this can be done only by good science education, so that the students can decide by themselves and by their knowledge and skills about surrounding world, about very different news which come from social world. So the news which are coming from media and social media. So now an example can be that somebody is writing that, oh, in Estonia will be tomorrow the hurricane and the 8-meter waves can come to Tallinn. So it's probably science education which could help students to decide, is it probable or very few very few probability. So it's but then the most or even more important question is how to teach what to do if some unknown events can happen, and how to bring to school those new situations which we have nowadays, because in most school programs and such kind of questions are missing at all. So it's not in learn books, so only teachers can bring this new knowledge into school and bring it to students. So it's a question about what teachers know about those unknown and probably coming problems, and how they can teach students to meet this. And Crystal brought a good example of already existing program in Estonia, which deals with climate challenges, and they try to, which is guided by university students. So because the new ideas and new knowledge is always coming from the universities. It's not existing in general teacher community. And this Crystal's project or program, they try to define what are the knowledge and skills which students knew or should know about climate change, and try then you try also to educate teachers, or yes. So it's probably the way, the positive way out can be just renovation or changing of teacher training and bringing such new ideas into teacher training. One point more was that some students already have anxiety about climate change and climate anxiety. And here, when we are going to teach the meeting with unknown, it's important not to let students think in the way that, oh, tomorrow will be something terrible and the next day will be more terrible things. So it's important not to give them such anxiety. So again, this is better to give them the strong and adequate picture of first of nature and environment around us, which helps them to be some strong personalities.
Thank you for the first group. This was an excellent point to make a stop, because after this discussion session, you can hear from the Marianne how about climate competencies. So the climate link is very good here. So from the group 2, about motivation. Yes, Rahel, please. I will give you this one also.
I have.
Okay.
I'm Rachel Mamlok-Naaman from the Weizmann Institute of Science. I'm here with the SciCar project together with Professor Ron Blonder. We are in charge of it in our Department of Science Teaching. In addition, I'm chairing the Division of Education at the European Chemical Society, and I used to be a titular member at the IUPAC, the CC, Committee on Chemistry Education. Something else about my past and future in our department. I also was the head of the Department of Science Teaching. I also chaired the Teaching Certificate License Program, and I take part today in the leading team of Professional Learning Communities, which is a very nice project which is ongoing in Israel, but maybe this is for next year. We'll talk about it. So if we are talking about motivation, there were quite a lot of issues which were raised. And in our group, we had Leo, Monica, Christy, Mari, and myself. And we started with brainstorming and how to deal with it and what to do with it. And it was about outdoor activities were suggested, and in order to encourage students, especially in elementary and in secondary school, to like what they see around them. Then we were talking about, it was Leo who suggested taking the smartphone and using it to understanding what's going on around us, not just, for the social media. Christy suggested, for example, ideas about survival. If we need to survive somewhere, what do we need, with a certain question, of course, and of course experiments at home and looking at what can we do, what's going on at home, in the kitchen, outside, and the micro world around there. And my addition was that students usually, they don't care not about how does the television function or the microwave, nothing, they don't care. We're just pushing the button. There was a survey which I myself conducted about what's interesting students, and when it came to their bodies or to their micro, sub-micro environment, then they were enthusiastic. Namely, if we talked about asthma, for example, why is it, what is it? They know they have a mother, a grandmother, or maybe themselves. So it's about the air pollution, water pollution, or if we are talking about the body, the human body and what's going on with the blood vessels, they were also something that had to do with them specifically, because this is the age. They don't look immediately at the global ideas and global things. But in our group, we certainly connected the motivation also to question number one, because they are today, they can, they are, how do you call it, fronted, or they can familiarize with what's going on everywhere, and they started to get interested. For example, a history teacher can talk about what's happening with the immigrants from Ukraine, and it has an impact on other kind of components like the culture, like economy, and so on. So we wanted to pack it out, and the suggestion was to use driving questions, to teach according to driving questions, and it's something that goes on for many, many years, and one of the leaders of this idea is Professor Joe Krejcik from Michigan State University. And there was, for example, driving questions, and we take the ideas about the smartphones. Smartphones can be used in different ways of understanding science. Here, there was an idea that the students will brainstorm and think about the questions that they want to ask about it. Questions about how they can use it in other devices at home, or how can it be done. And actually, it's based on physics principles. Then, how will your body react while climbing the Kilimanjaro? It's in biology. I told them that I know how will my body react and why, but what about them? What about the Kilimanjaro? What about height? What does it do to us, and how? We can add to it about the Kilimanjaro, about the boiling of liquids, of water, of high elevation, low elevation, and there are a lot of questions to be asked here. What kind of food do we take with us, and so on. Another one, for example, how can we examine the air quality around our house or our school, not more. And this is also something that has to be done. Then another one, why do puddles dry during the winter? Because we know in the winter the temperature is low. And in order to have this evaporation, maybe we need higher temperature, so it's a misconception. We need to cope with it. Another one, and I have 3 and I finish. Why shouldn't we use disposable plates? Why? It's so easy, and why does it harm climate? So here we're talking about polymers and everything around it. How will we be able to survive in extreme weather conditions? This was Christy with the survival, and she said the teacher has to be charismatic, but not all the teachers are charismatic, so we need to think about other things. And last, what is the benefit of vaccination, which is very close to what happened with the COVID, and somehow trying to cope with superstitions. So by this, we are talking about maybe how students will think a little bit out of the box.
Thank you, Rahel, and I'm sure that Ron can very nicely continue from the motivation presentation here. So, group number 3, who would like to talk? Janari, I will give the microphone for you.
Thank you. Hello, everyone. My name is Janari. I'm from the University of Tartu. It took some time to form our group, but when we eventually did, there were many experts and me. So first, what we discussed was how can we even know what the future holds, and what is a science-related career, right? Because even a fisherman needs some sort of science, or his instruments are based on science. So everyone needs science, right? There's food science. Someone working in the kitchen needs to know some chemistry. So basically everyone would need to know some kind of competences for the future. Now, what would they be? Someone mentioned curiosity. For example, knowing how or being interested in how things are made of, like breaking apart your computer, something like this. But in the end, we landed on communication and being prepared for something that we do not know or what we don't know how the future is going to turn out. So we need to talk to each other, understand that everyone is different. We have differences in understanding the future, the present, and even the past. We need to collaborate, and together we can be better prepared for the future, because each of us is our own expert in different area. So, yeah, I think that was the conclusion that we made. To be prepared for something we don't know, we need to be curious, and we need to be adaptable. Yeah, I think that was the word, adaptable. So yeah, thanks.
Okay, thank you, Janari. And now, the last group. Let's go towards universities.
So we will have lost the most active participant, Helene. And it was not my own choice to be here right now, but okay, we had Hailey in our group, Ron, Helene, as I said, Meili, Mario, and that's all. Yeah, exactly. I am Katrin Vaino, a researcher and a teacher educator from the University of Tartu, Center for Science Education. So it took a long time from us to introduce each other. We did like 2 turns, first in Estonian, then in English. So, but now we at least know each other well. So then we had many ideas, but if I miss something, then you will, you know, compile my ideas. So first, the first idea was that we should involve more student teachers, even bachelor teachers, to the projects, maybe research, maybe developmental projects that are carried on in our university quite early on. Not only that they do like masters or this is part of the research, right? But it could be even more. So, and I think, yeah, this could be a gap really that we could fill. Hailey said that it's quite normal in your unit that, okay. So this might be one thing. Then the track, I don't know, researcher track in education is kind of specific as it is in medicine, maybe, that people become first, they want to become a teacher, then they maybe teach, and then they think, why not to actually research the thing called education, right? So, and now the question is how to, let's say, hire those potential people to PhD studies, doing some more research already. And we found that the bridge, kind of flexible bridge for it, could be a micro-funding scheme, but this cannot be only, that I started to think right now here, that it cannot be only kind of university's business, because university cannot solve all problems in society. It should be more societal thing that could support this track. So, but anyway, micro-fundings for teachers who are teaching, who have lots of hours in school or lessons in school, but they need some time. And those who are interested, they just think about that, oh, I may be interested in doing research. I will try it. And those projects could be really like micro-projects, like action research projects. They study their own things that are really important to those teachers. that come from, grassroots level. So, and then they could see and they apply for these schemas, the calls that are announced, and there are also maybe conferences designed for those beginning researchers, and it well builds a bridge between school and the further PhD studies, because now, after doing this small research, they have something already in their, to present when starting the real PhD. So, and maybe some, as we discussed in our group, some people may recognize that this is not for me, actually. Doing research, this is not actually for me, because it's like too late if you are already a PhD student to recognize that, no, this is not to me. I'd like to be just a teacher or something like that. And there was one idea more. It came from me, actually, that how about 2 years licentiate programs? Did I spell it right? I don't know. That we have many PhD students, not many, but we still have them, who quit after some years. But if it would be broken down to like 2 years and 2 years, maybe they still are able to finish the 2 years program. They get the kind of, certificate, and they still, it gives more motivation maybe to at least finish this stage. So we didn't do research on that really in our group. We don't know what are the kind of, maybe there are pros and cons in different countries it has been used, but it was just an idea. That's all. Thank you. Or, I don't know. Would you like to?
Okay, thank you, Katrin. And this is almost the end of the discussion session, but do we have one or two quick comments from the audience against all over the topics? Or you can keep your questions for the upcoming presentations, because you more or less discussed around the topics that are upcoming presentations, or in the end of the day in the panel discussion. I guess point 3 and 4 are especially part of the panel discussion also. Okay, I guess we don't have any more direct comments in this session, so thank you for all actively participating and expressing your ideas for the audience here and online. So, thank you.
So now we're moving to the next presenter. She comes from Finland, but we had to make a slight change in our program. So the chair of the session is, in spite of Professor Priit Reiska, Associate Professor Anne Laius. So Anne, please, the floor is for you.
Hi to everybody. I'm pleased to introduce the next presenter, Anne-Mari Sandala from Finland, Helsinki University. She's a meteorologist and designer. Her doctoral research is about atmospheric and climate change research team. Her own topic is mostly climate change leaders and climate competencies, which we are very interested in. Excuse me. And she's also developing multidisciplinary courses about climate change and sustainability. And mostly she researches different organizational climate change experts, leaders, and students of Helsinki University. Floor is yours.
Thank you. I'm grateful to be here and for this opportunity to present our latest research for you. My name is Marianne Sandala, and this interview study, which I'm going to present to you, I have made together with my colleague Joula Siponen, who is also working as a doctoral researcher at the University of Helsinki. we both, me and Joula Siponen, we work at the Institute of Atmospheric and Earth System Research. And we are in a research team which makes research and develops climate and atmospheric education. Among atmospheric scientists, there has been going on discussion about climate expertise. Who is a climate expert? And then Laura Riuttanen, who is my supervisor as well, and others made a study. They asked climate scientists about what do they think about the climate expertise, what kind of competencies you need to have. And they were comparing those answers with sustainability competencies. And sustainability competencies have been defined already during the past 10 years, and I think they are quite widely considered in the education as well, at least in Europe. Their result was that the sustainability competencies may differ a bit from climate change or climate expert competencies, and they came to a conclusion that maybe this topic should be investigated more. So now there is this 4-year project going on, learning of the competencies of effective climate change mitigation and adaptation in the education system, for short ClimComp. It's funded by Academy of Science Finland, and this interview study is part of that project. It's made in collaboration with Finnish Meteorological Institute and University of Helsinki. And the collaborators are atmospheric scientists, climate modelers, educational scientists. Jari Lavanen is involved in that project as well, and psychologists. So in that project, we are studying what are the competencies and how they are learned and taught throughout the education system. Educational scientists study optimal learning moments, and then the aim is to propose systemic changes to the education system to better teach and learn the climate competencies and develop new tools. We have, or University of Helsinki coordinates the network of higher education institutions in Finland. It's called Climate University, and together they have developed kind of a course package, which are called Climate University courses. They include multidisciplinary courses related on sustainability and climate change, and I think, at least on my side, this project will promote those courses, and when we know better what should we teach and how, then we can make those courses even better, and we are developing one new course as well within this ClimComp project. And this interview study is also part of my doctoral thesis, which is so far funded by the Finnish Cultural Foundation. So here was the little bit of a background for this interview study, where we are focusing on which competencies, knowledge, skills, attitudes, values are needed for climate change mitigation and adaptation in Finland. Here you can see the overall research process. So I have been talking about the interview, but actually it includes a questionnaire as well, conducted by Joula Siponen in 2021 already. The questionnaire was sent to different sectors in Finland, different kind of organizations, trying to reach different industries and fields. Then based on those answers, we created together a competence map. And now, with these interviews, we are developing that map even further. And the interviewees are the same people that were, or the same organizations at least, that were answering that questionnaire as well. Right now we are in the analysis phase. We want to create a visual competence framework, and we are writing the article, which will hopefully be published in next year. And we still want to validate our framework with asking feedback from the interviewees. Some details about these interviews. So they were thematic. We had 22 different organizations and 22 interviews. Me and Joula were interviewing together. Mostly we had one informant in one interview, but we had a couple interviews where there were two people from that organization. As I said, the organizations had replied to the questionnaire, and the people were in the positions where they had titles like environmental manager, corporate responsibility manager, or climate coordinator, etc. So they were the people who were driving the climate change mitigation efforts in their organizations. The interviews took 1 hour, or one interview took 1 hour, and they were semi-structured, so that we wanted to take advantage of their expertise and focus on things that they were, or things that were important to them. The first half an hour we asked open questions based on the questionnaire, like we asked them why did they answer in a certain way, or do they have some more to say on the topic. And the second part of the interview, we showed them the preliminary map we had constructed based on the questionnaire results, and we were developing the map together with them during the interview, asking them to add things and commenting and what is most important or least important for them. And I guess you wonder, what is this map we showed? It's this one. You cannot see the small texts, but they were like classified into three blocks, and red ones are industry-specific skills and technical climate change mitigation and adaptation know-how. And blue ones are related to interaction and socio-emotional skills. The green ones we called sustainability competencies, since they are the same that are defined by the popular article called Week, or Week et al. Has written that article. But just to remind that this is more material-based than a theory-based study, and these these competencies were mentioned in the questionnaire results, but they are also emerging in sustainability theory. And we use this definition of competency, knowledge, skills, values, and attitudes as a tool to explain what do we want to ask from the informants, so that they understand that, okay, it could be also value or attitude instead of just knowledge, for example. During the interviews, we added yellow notes as the interviewee gave us the comments and additions to this map. And based on those yellow notes, after the interview, we filled this map with these red and blue and green boxes as needed. And then we started the next interview, and again the same. So in every interview we had a slightly different map to show them. And this is probably the one which was almost the last one, maybe the second last one from the second last interview. Yeah, and then we marked what do they think is least important and most important by these stars. And when we were showing the map, we wanted to focus more on things that weren't yet discussed on the first part of the interview. So during the open discussion in the beginning of the interview, we marked the brown stars to the topics that were already discussed. And now we have been analyzing these results, and so far we have recognized 5 competencies. I think during today, when I've been talking about competencies with some people, or in the beginning of today when Mia showed the slide of future transversal? What? Yeah, transdisciplinary competencies. I think you can see the same things here very much. So there is a socio-emotional intelligence and impactful communication, which means ability to understand people and being able to motivate and convince others to take action based on scientific and transparent, yet emotionally appealing interaction. You need to kind of assimilate to other people. And then scenario-based decision-making is important, that you have the ability to develop and implement innovative strategy based on future climate scenarios. So you should really consider those scenarios heavily in your strategies. Then the green one, continuous learning and competency development supported by networks. Many of the interviewees said that they cannot know everything, so networks are really vital for their work. And so they need ability to constantly update one's knowledge and competencies, utilizing this peer learning, but still they need good literacy skills as well. And these things promote collective competence via their networks. The next one, of course, you need, when we talk about climate competencies, you need a systemic understanding of climate change as well, and which is very important is the effectiveness of actions, that you can understand the effects of climate change on natural but also on societal systems. And then you can assess appropriate methods of mitigation and adaptation in different contexts, or the context that is specific to you. And last but not least, I think courage and resilience. This refers to inner resilience and ability to withstand uncertainty while having an open mind, being curious, and courage to drive transition. Below, there are climate values and justice. We were discussing this topic, and it came out from their answers, but it divided opinions, especially these climate values. Some said that they don't consider those so important. They're doing their work, and maybe nowadays it's like when we, at least Finland has this national goal to be carbon neutral in 2035, I guess. So it already like comes from outside these goals, and they don't see that the values are so important. But some of them said that they are crucial, especially if you want to have a leading position in climate actions. And these are relating to each other and affecting to each other, these competencies. Together, they support the implementation of climate change mitigation and adaptation measures and projects. And this diamond is kind of building up from below, so that courage and resilience is very much needed in all of other competencies. It requires courage to regenerate and have, and it's important to have open mind so that you can continuously learn and develop. It also requires courage to influence other people, open your mouth, and resilience to face the conflicts with others or within communication. The decision making requires courage as well. You need to have to do courageous decisions and maybe take risks. And you need ability to tolerate uncertainty as well. When you're taking risk, there are uncertainties. So it was quite many people mentioned that one. And then it requires also resilience to accept this topic of climate change, since it's so large topic and complex. So it's not the easiest one. Learning is feeding to other competencies as well. If you build networks and learn in these and share your competence, they provide support for courageous actions and to withstand the uncertainty. Then continuous learning also, of course, supports the development of knowledge and understanding. And collective competence generates power for change as well. The relevant networks maximize impact of communication. You know the people like who you should go to talk to get your project forward, for example, or who you should hire to have a successful project. And the essential building block is the systemic understanding. It supports identifying and building relevant networks so that you understand, you see the society in a systemic way, so you understand what kind of networks you need and you can identify those. Understanding and knowledge enable also effective communication. You can convince others when you really know the topic you're talking about. Understanding and knowledge support also decision making. Then there is this socio-emotional intelligence and impactful communication. It helps you to build networks and develop competencies, as well as influencing, like you want to influence in decision making. Many times these people are not in the position, they don't have the mandate to do the big decisions, but they need to influence on different directions. So it requires these socio-emotional skills and communication. Then there is this scenario-based decision-making kind of, already it contains the implementation or maybe at least actions in a sense that you do action work when you make a decision. And it's important to share the best and worst practices with the community to develop the collective competence. Then we have some ideas how or what could be the application of the competencies. It could be applied to higher education to make a climate change education more holistic and to consider better these transversal skills as well. It has already considered in planning in-service training at the University of Helsinki. And what I didn't probably mention yet so clearly is that when we were interviewing, we asked these competencies in the individual level and at the organizational level as well. So this is the combination of those. So you could use this as a competence, like when you want to manage your competencies in organization, or you could use this as a tool for recognizing your own competencies. I think one person cannot have all of these, but you can still see what are important probably to you and what you would like to learn more. So we are soon coming to the end, and we are hopefully having article coming next year. Let's see in which publication. But now I will thank you for your attention.
Thank you, Anne-Marie. Now it's a very good opportunity to ask questions from Anne-Marie. Who wants to ask? Yes, please. The microphone.
Thank you. It was really interesting and a very nice designed research. I would like to ask, you mentioned in the beginning, this is the climate competence for Finnish people. Why it's specifically for Finnish? Why don't you think it's an internationally global competence?
Yeah, well, I hope it's national, even global, but I probably I was trying to say that the organizations were like Finnish organizations, so and in that sense it applies at least in Finland. Yes.
Thank you.
Okay. I would like to ask about the support. Maybe you mentioned it and I didn't listen or didn't hear. Did you get a support from stakeholders or the data which you got? Were they willing to give it to you very, in a good way, or did you need just to dig it from what's going on around?
Do you mean that when we were having this discussion with them?
Yes.
I think it was depending on the person who were talking, with who we were talking to. Some of them were very. They had a lots of thoughts, and some of them were maybe not so. Or we had maybe at least one or two who were not so. Like maybe I could say not so deep. They didn't have that deep understanding of climate change, and their industry was. For example, if you have some kind of consulting company and you do the mitigation efforts in your own organization, then you don't. It might be quite like trivial that you just adjust the energy consumption and think how people come to work, and that's kind of all you want to do if you, or all that you can do in your own organization. So in those cases, maybe we needed to a bit dig the answers, and but mostly I think it was quite nice to talk with them, and they. But still, I felt a bit that this 1 hour interview, like how could I say? In the end of the interview, the discussion was going on really well, and in the beginning it was maybe. So I was wondering if we should have showed the map already a bit in earlier phase to kind of familiarize with the topic.
Were there people who refused to answer your questions from the industry or something, who didn't want to talk?
Do you mean that if we asked a question they didn't want to answer? Not really, but it's also, I mean, if we would have the exact questions that we want to present, maybe that could have come to, we could have experienced that, but since it was semi-structured and we had these themes, what we want to discuss with them, but still they had the opportunity to discuss. Yeah.
Thank you. More questions, please? If not, can I? You said that you developed the courses of climate change and sustainability. What is the difference? And what is the relationship between sustainability competencies and climate change competencies?
I think that's one what we are trying to investigate as well now. I think it's also hard to distinguish those from each other, and there are different views on that. For example, you can think that climate change is one of the sustainability issues, but you can also think that it is a bigger, like, it's very much related to sustainability, but it's kind of a parallel topic. So, and as I showed you the map of competencies, it was including these key competencies of sustainability as well. But I think these competencies that I showed you, they are more precise and more practical things. And like beforehand, other competency definitions are maybe more theoretical, but this is like a ground level study, and we got the more practical information from those. But I think they are coming together in these results, and they have very much in common.
Thank you. Any ideas? Yes, please.
Thank you. So people talk about such a term like climate change literacy. So what's the difference between climate change literacy and climate change competencies? Or how you describe person who is literate in climate change?
Yes, well, I'm not sure if I'm actually so familiar with the literacy term, but I think that I don't know, can literacy include the things like attitudes? And if it can, I don't know what's that's a really good question, actually.
I can try. So these questions have been asked from the professionals who are working in climate-related issues in companies and organizations. So they are in their job is fully focusing to this topic, so they need certain type of competencies in this job they are doing. And maybe literacy, we are discussing about literacy when we are thinking what everybody should learn at school, and it's a little bit different view to the topic. This is more specific to the people who are working. So I hope that somehow we can continue that direction to analyze. But it's an excellent question. So what everybody should know and what should specialists know. But maybe if I get the microphone, I can ask that. So you have been asking from the experts that you are working in this field and what kind of competencies you have. And then you come to this diamond model. But if you have asked also that what kind of competencies they lack, so what might be the answer then? So where are they good enough, and what is lacking in their job?
Actually, yeah, we were asking what do they think they would need? What are they lacking?
What are the recommendations based on that?
Well, I've been thinking one thing that they mentioned was resources to keep up with the new information. But we didn't investigate what is the reason for that. Like, do they really have so little time? Or should they have actually a better understanding of climate change and scientific information? Would it help them? I don't know. It doesn't answer to this question. This study doesn't answer it, but it was one.
May I just try and ask if I understand correctly that when we're talking about climate change, it's climate change, but sustainability consists of other kinds of components. It's not only the climate change which we are talking, it's also we're talking about what's around us, what's surrounded us, and it's more climate change. It's also the influence of people and all that. Okay, but sustainability has components, just like we are talking what's the interactions between the whole ecology around us. Of course, it influences the climate change, but it influences other ingredients as well, who afterwards will influence the climate change. If I understand it correctly, I'm just asking you.
Well, I think you can see it in that way, yes. And I think there is different opinions on that. I think you don't have the correct answer, or I don't have the correct answer. But in a sense, the sustainability, I think it's the wider topic.
But in education, if we want to, I guess that we need a little bit to differentiate it a little bit. Everything moves afterwards towards the climate change, but we need somehow to start from other. That's what my idea is in educating. What's pollution? What's going on? with the let's say disposable, and so on and so forth. And this is sustainability, sustainable way of living, and this all will somehow lead us also to the climate change.
Yes.
I suggest. It's just a comment.
Yeah,
Thank you.
So enough to ask only theoretical questions. So let's ask something which is practical. What was the most surprising finding from your interviews? But you didn't expect to get this sort of answer or something. So just make people aware. So
Yes.
some few examples.
Probably these socio-emotional skills, so that they quite a lot mention that it is a challenge, and when they are talking to different people trying to influence and proceed in their work, they really need to think carefully how they will present their ideas and what are the other person's motivations. And I think this came out almost in every interview.
Thank you. Any more practical questions? No. Thank you very much.
Thank you.
Once more. And good luck with your doctoral studies, and let your article publishing dream come true as soon as possible.
Thank you.
Now we're a little bit ahead of time, but I think that we need maybe more time at the panel. So let's move forward and now invite Rachel, not to introduce herself, but to introduce Ron. You did already that.
Yes.
So now it's your turn.
Okay. Okay, it is a great pleasure for me to introduce Professor Ron Blonder, a good friend from the Department of Science Teaching. Actually, she's the head of the chemistry group in our department and the head of the Rothschild-Weizmann Master Program for Excellent Science Teachers. Her research is concerned on two central dimensions in chemistry education: connecting high school chemistry to contemporary chemistry research by focusing on nanotechnology education and supporting teachers in integrating technology-enhanced chemistry teaching. It was found to be very useful during the COVID pandemic and enables her to support the remote teaching of high school chemistry teachers and the lecturers at the Weizmann Institute of Science. Ron has applied the results of her educational research to chemistry teachers' professional development. Today, she will talk about introducing contemporary research topics into school science programs, the impact on students' motivation to become scientists. So please, Ron, we're waiting.
Thank you, Rachel, for the nice introduction, and thank you, Mia, for the invitation to present my research here. Okay. So, as Rachel said, I'm from the Weizmann Institute of Science in Israel, and this is a research institute, a very small university that has only research degrees, in master degree and PhD degree in the science fields, and also we have a department of science teaching where I'm doing my research. And before I start, I would like to thank in advance to my research group who actually do all the work that I'm just presenting. So this is a photo of almost all of the research group. I want to send you back in time, okay? And I want to ask you to try to remember when you learned in school. What did you learn in the science lessons? What did you study in the chemistry class? Okay. So for some of you, it's not a long way back, but for some of you, it's quite years ago. Try to remember, what did you study in the chemistry lessons? I guess that if you thought about your chemistry lessons, this was one of the images that you had. And it doesn't matter when did you study chemistry, 40 years ago, 20 years ago, 5 years ago. I guess this is what you studied. And you know, this is really, sometimes when I think about what we study in school, this is really, for me, it's amazing that it almost didn't change during the years. While chemistry in the laboratories, in the research groups, is really advancing all the time. We have organic chemistry, solid state, and we have biochemistry and biomaterials. We have colloids and nanochemistry and more, medicinal chemistry, catalysis, analytical chemistry, sustainability, of course, and global challenges, computational chemistry. Almost nothing of this contemporary research reached to school. We teach about the Mendeleev periodic table, and we teach the basic concept. And you might say, okay, this is a basic. We should start with the basic, and then to build upon it when they reach the university. And we teach about Mendeleev, but don't we give the student a wrong image of actual science? Because this is not how scientists look like today. For example, here are the young researchers from a chemistry faculty from the Weizmann Institute. They don't look similar to Dmitry Mendeleev. So what do we do when we just teach the old concept of chemistry and we don't even present contemporary research and contemporary scientists? Maybe we should think about how to bridge this gap between school chemistry or school science in a broader way to contemporary chemistry. You can ask yourself, why should we do it? Okay, we teach about Mendeleev, not about the chemists today. But as I will show, there are studies that show that when you teach school students contemporary science, you influence their motivation to study science. You present them with the actual image of science. You attract them to choose scientific careers, and also you reduce the gender gap, because today scientists also include women, and they can create a model for young students also to become scientists. So there are good reasons, and let's check in more details more of the reasons why should we bridge this gap between school chemistry and contemporary chemistry. Okay, gender gap. I'm sorry. Okay, I'm sorry. So, how can we do it? How can we bridge this gap? So, the first idea that we can think about it is to take or invite high school students or high school teachers to active research laboratories. So if a student joins a lab, he or she can image what is really to do research in a lab. We can also think about inviting the students or the teachers to participate in scientific conferences and to take part in the actual communication process of science and contemporary science. We can present them with videos, interviews with real scientists, and also we can design outreach activities to invite students, bigger groups of students, to research institute. So let's see how these possibilities really impact students' motivation or other aspects. For several years, we invite about 100 students to a conference in Israel that is called Nano Israel. It's a scientific conference about nanotechnology. Scientists that do research in nanotechnology from all over the world arrive to present their research, and also people from the industry. So we invited the students to the conference, and we studied how the participation in the scientific conference impact these students. And in this graph, I differentiated between two kinds of students. Students who had background in nanotechnology. They study advanced course in nanotechnology, and I'm talking about school students. And we found that participating in this conference impact students who had background in nanotechnology, but also students who really came from ordinary science class and didn't have previous background. It impacted their, first of all, we asked them, what did you do in the conference? I'm sorry. And so they listened to the lectures, they visited the exhibition, the poster exhibition, and they talked with the PhD student who presented the work. They read the posters. So they didn't sit at the side. They participated in the conference. And we found that this participation actually impacted their perceptions regarding science. First of all, all of them felt it was worthwhile to attend. You know, to come to a scientific conference, it's a totally different image of science. Because when students image scientists, they actually have this picture of Albert Einstein, you know, the white hair person who with a white coat. But in the conference, people look different. Scientists look, you know, like we look like. So the student can see a different image of the scientist, and they learned about opportunity, employment opportunity within the nanotechnology industry. They also said that they would like to study nanotechnology or science in the future, and most of them also said that they would like to work in research in nanotechnology in the future. So in this way, when we invite students to participate in a real scientific conference, we can impact the way they image the science and also their future career aspirations about research and about other aspects of science careers. So this is one way to attract students to science career and even research career. But there are other ways. For example, the outreach activities, and a lot of universities and science and research institutes provide such outreach activities in which they invite students, classes of students, to participate in an activity that expose them to real nature of science development. And I would like to present an outreach, very shortly, an outreach activity that we have at the Weizmann Institute of Science. We have this very, very friendly scanning electron microscope, the SEM. And we chose to design an outreach activity in which the student operates the SEM, the electronic microscope. We chose this, the SEM as the center of the activity because we know that scientists use the electron microscopy to characterize their systems and they use it while they do their scientific research. So the SEM is an equipment that is a part of authentic scientific skills that scientists use. Also, the SEM has the ability to reach very high resolution imaging, and it exposes students to the beauty structure of nature or of samples that they measure. Another thing, the SEM has this EDS ability in which it can identify the elements in the sample. So it is well connected also to chemistry, biology, physics, very interesting. And in addition, we found in the previous study, when we interviewed scientists from the physics department and asked them, how do you communicate your research to students, most of them told us that they used to present students with results from characterization methods. So they show images from the electron microscopy. So it's a way to communicate in a very friendly way research results. So we said, okay, so if it's so effective, we will take the SEM, the electron microscopy, we will design an outreach activity and invite students to work on the microscopy in order to impact their image on science. So we decided to study this activity, the impact of the activity, using a unique perspective that is called a perceived authenticity. When I say authenticity, I mean an ordinary way of doing science. So we don't present science as it is presented in school, answering questions that nobody asks, nobody of the student, but we try to present an authentic environment of research laboratory, an authentic way of doing research. So we use a measured scale to measure what is authenticity students think about the activity. So the first item, I learned how work is done in research. The second one, I learned about current important research question topics. The third one is very important. It is connected to the previous lecture. I had communication with scientists because communication is an essential part of the scientist's work. Students are not aware that this is part of scientists' work. And as you see, it received a high score from the student. They said, I saw an actual research environment, for example, research lab. I got to know possible working area in the research. And of course, because they work with microscopy, electron microscopy, I learned about research devices. This got the highest score. And I learned about different ways to analyze and interpret results, data in science. As you can see, this one got a very low, comparing to the other, low score. And we learned that we need to improve the outreach activity in this aspect of analyzing the data. Just to give you an impression, when we asked them to fill in the questionnaire regarding their own school science laboratory, the score was really low. So the score of the authenticity of the activity was very high. It means the activity reflects authentic science as a student in the student eyes. In this way, we were able to expose a lot of students to authentic research environment. But let's see a different approach. For example, joining a research lab. Okay, opening your research lab to students or to teachers. While joining research labs, when we conducted some research, we found that this is a very good way to elevate student motivation and interest in science. By doing that, first of all, we invited the teachers. Here in the photo, you see teachers. Each teacher joined a research lab and for 2 weeks conduct research with the scientists there. Then students joined the lab. In our European project, SciCar, we took this approach and we conducted a different, another stage. We call it job shadow. People from one university joined and from one expertise, for example, from science education, joined a research laboratory in science and learned about how the research is done. And last May, we had a project meeting at the Weizmann Institute of Science, and you can see here the partners who participated. And some of the partners actually joined research labs in Weizmann Institute to see how actual research is conducted. So all this experience that I showed are really taken from the informal science education, going to a conference, going to a lab, doing outreach activity. But if we think about the hours our students spend in school science, it's reasonable to think that maybe we should also put effort to introduce contemporary research and contemporary science into our schools, not only the informal activities, but also to the formal educational system. But can we bridge, or can formal education really bridge the gap? Because let's think about that. The teachers in the formal education, if we want to introduce it in the formal education, the teachers should deliver or introduce the student to contemporary research. And this is a real challenge because they are not part of research activities. There is a knowledge gap and also skills gap. In my research group, we study this, we are focused on this challenge. And we try to, and we think about the question, how do chemistry teachers develop when they interact with contemporary research? And we try to develop models for professional development of teachers in order to support them in reducing this gap. So we can think about why teachers? But I want to cite here a very known report that is called the McKinsey report. In this report, they studied very successful educational systems around the world to find what are the characteristics of very successful educational system. And they mentioned two main conclusions. And it might seem trivial, but it's important. They say the quality of an education system cannot exceed the quality of its teachers. Okay. And the only way to improve outcomes is by improving instruction. So no miracles. Teachers have a central role, and we should focus our attention on supporting the improvement of teachers. We should think about how to accept good teachers, good candidates to be teachers, and how to continue developing their abilities and their knowledge and their teaching. But teachers' knowledge is a complex construct. It's not enough to know science in order to be a good science teacher. We call it content knowledge. It's not enough to know how to teach generally and to have pedagogical knowledge in order to be a good teacher. So it's, for a long time, Schulman gave the name PCK, the pedagogical content knowledge. You need to know the science. You need to know the teaching, but you need also to have a very specific knowledge how to teach the certain contents. And this includes students' misconception and how students learn scientific concept. This will instruct the way teachers will teach the scientific concept. So if we want the teachers will be able to introduce the exciting contemporary research while they teach in school, First of all, we need to help them learn or develop their content knowledge of contemporary science, and then to see how they can integrate it in their teaching. So I present here a course that I developed for chemistry teachers in Israel about nanotechnology. And a lot of courses were developed around the world to expose teachers to contemporary research. And after this course, we measured the teachers' knowledge, and we found that they really improved their knowledge regarding all the concepts that we were teaching. But, as I said before, it is not enough to have the knowledge in order to really bring these topics to your students. And by the way, we also did this course in an online environment for several times, and we found that also in the online course, they really improved their knowledge. But content knowledge is not enough. And we need this pedagogical content knowledge, the PCK. Teachers need to develop their PCK, the pedagogical knowledge, how to bring contemporary chemistry to class. So after they learned the course and they really improved their knowledge, when we talked with them, they said, okay, I feel that I understand, but this is too difficult for my students. Or they said, I feel that I understand, but I'm not an expert enough to teach it. So we thought, okay, they are right. They have the knowledge, but what about the pedagogical content knowledge? And first of all, we develop a teaching model. For example, in this photo, you can see a really model how the atomic force microscopy, never mind, it's a very nice microscope that presents the matter in atomic resolution. So we created a teaching model, and we invited teachers to participate in the workshop and to build their teaching model. And this created a better opportunity for the teachers to take it to their own teaching. And here you can see one of the teachers using the model and really introduce her student to the atomic world exposed by the atomic force microscopy. In this stage, we developed, together with Rachel Mamluk Naaman, who sits here, the three-stage model for development of teachers' contemporary knowledge. First, to learn the content, then to provide the teachers with tutorial that also expose them to advanced pedagogies, and then to do the adaptation to education. So they have the knowledge and the confidence, and then they have also pedagogical content knowledge, how to teach these advanced topics. Is it enough? More advanced, I will not go into the details of this model, but more advanced models of teaching, of teachers' knowledge, says that it's not enough. It's not enough to have the knowledge, that is the upper square, and not enough to have the PCK. Because after you have the PCK, the big question is, will you take this to your class? Will you take it to your student? And according to this model, there are amplifiers and filters that are teachers' beliefs and attitudes. And this actually can block the transformation of the knowledge and the programs to the students. And as we heard this morning, a lot of reforms are done, but almost all of them, they don't succeed. Because teachers, if they think, why to change? If they think, I'm a very good teacher, why should I take risk? Why should I change? This is an attitude that blocks any reform or any change in teaching. And these attitudes, they are tricky because they are different between each teachers, because each teacher has a different student, different background, different beliefs. So it's really personal, different between the teachers. And also, something else that is really different between the teachers is the classroom practice, because the context, the educational context, differ from school to school, from class to class, from year to year. So the context is different for each teacher also. And only then, only when we reach the classroom context, the innovation will reach the student. So there are a lot of stages that might block the innovation from reaching the students. In a recent review paper that I wrote together with Vicky Veschio from the US, we reviewed different research about teacher professional learning communities, and we found that there is a need to do research about a differentiation approach for teacher professional development. And this is reasonable if we think about the different context of the teachers, the different educational settings. Why should one professional development course suit all the teachers? When we think about teaching in school, we really agree that the students are different, there is a heterogeneous class, and we should think about how to include, how to do inclusion when we teach in high school. But why working with teachers is different? Teachers are so different. We should treat them as individuals. They have different students, they have different philosophy, different beliefs, different knowledge, different seniority. Sometimes in a course you see teachers with 1 year of experience and teachers with 30 years of experience. And of course, different context. And I will not go into a lot of details, but we're doing something that we call research practice partnership. And this is really communicating with this first lecture that we heard today. In this partnership, the teachers, they have a very important role. They design the nanotechnology unit for their own student after they learn the content. And even if two teachers take the same content from nanotechnology, for example, they will design different units for the student because they have different educational beliefs and different students in the class, different level, different philosophy of the school. Then after the design, they implement the unit, they implemented the units in their own class. But before they do so, they develop some research tool to measure the influence of the unit on the student. So the teachers do the development, but also develop research tools to evaluate themselves, okay? They actually do a research project. And then they write a report about the process. It's not just, I'm trying to do it. It was nice. I saw that the students were very happy. No, I developed a model, I developed research tools, I measured the impact of the model on my students, and I report about it. And by doing this circle of research, they were able to distinguish what part of the model that of the unit they developed really was effective, what part was less effective. And when we interviewed these teachers 5 years after the intervention, after they wrote the report and presented their research, we found very interesting results. First of all, they kept teaching these units. It was sustainable. It was not after we left, everything was disappeared. and they didn't have to do it. They wanted to do it. But we also found that the variety of teaching approaches that they used, they transferred it to other topics that they teach. Because when they taught this nanotechnology unit, they used really fancy pedagogies because it was something that they wanted to try. But we found that they used these pedagogical approaches even when they were then using to teach their regular chemistry content. And this is really interesting because I think that when you work with teachers as partners, they gain, as you see, but I also, and Rachel and me that we did this research, we also learn a lot. For example, we learn a lot what did they choose to teach, how did they choose to teach, and the research was really relevant to their actual practice. So if we look at the impact of teachers' knowledge and belief, it's a very good way to bridge between school science and contemporary chemistry. And we should consider the contents. We should consider the pedagogical considerations of the contents. And in here, the role of the teachers is really very essential, because I can provide them with pedagogical considerations, but they are the experts in teaching, so this is the part of the teachers. The teachers also identified the possible connections of the contemporary research to the existing curriculum. And if they don't find connections, they will never introduce these topics in their teaching. The teachers think about their own student and their own teaching sequence when they want to bridge this contemporary chemistry to their own teaching. And lastly, it's important to touch and be aware of their beliefs and attitudes. So, bridging the gap between school chemistry and the contemporary chemistry is important. It's a short summary. It's presented students with the actual image of science. It elevates their motivation to be part of a science community. It reduces the gender gap, and also it elevates their motivation to pursue scientific career. And I think that the combination of informal and formal science education is a very good way to try to bridge the gap between these two entities. And in this slide, I would like to thank again my research group and to thank you for listening.
So thank you, Ron, for your comprehensive, for your very interesting talk, which is also close to my heart. And if there are any questions, please. It's like, speak now or never.
So you asked me, or everyone, to recall our chemistry. I can tell you when did I decide for physics, when organic chemistry has started. And actually, when I looked at your course dedicated for physics teachers, I discovered with pleasure the course of introductory atomic physics, which I was in my active years delivering to first-year physics students in the university. So I still don't see and this is more or less a question or provocation, I don't see that when you start with interference and you arrive to nanotubes, where you can pass over the potential blockade when you related to organic chemistry. Organic chemistry is the most important, probably, in industrial applications. However, what was missing for me is the way to simplify, to systematize what I am learning. And I passed to physics when I understood that inorganic chemistry I can understand fully in terms of atomic, the electron shell rearrangements. With organic chemistry, I would confess that even today, I don't have a true feeling of understanding. So how could we teach organic chemistry in a way which makes attractive for students and attract them to sort of to very important industries, the medical related, medicine-related industries.
Okay. So thank you for the question. First of all, I didn't came to save the whole world. So, no, but I'm joking. If I think about the issue of organic chemistry, for example, and try to connect it to contemporary studies. So even in your questions, there were hints for some possible solution. First, if I would like to connect it to nanochemistry, I can think about self-assembly. Self-assembly, it's an amazing word. If you are smart, if you know the properties of molecules, you can design molecules, organic molecules, that will self-assembly in structures that will create new properties. You can create nanofilters that will filter water and then disassemble in order to take out the dirt and reassemble again. You can create nanoparticles by self-assembly that will carry drugs to do specific treatment for cancer. So organic chemistry is an essential part of nanotechnology, of very smart medicine. And for example, even if you think about the vaccination for COVID, it is based on understanding of very simple concept in chemistry, intermolecular interactions, very simple concept in chemistry that students from 9th grade can understand, and it's based on self-assembly. And these particles, it's so easy to understand how they work, and it's more interesting than just to remembering the names of the IUPAC names of the organic molecules. So you can connect everything that you teach to contemporary research. And I know that in physics, it's not the picture, because the string theory, it's really difficult to connect to a basic concept. But for example, in chemistry and biology, you can really connect almost everything that you teach to amazing research that is conducted now. But you need to know good the basic concept in chemistry, and also to know very good the basic concept of the contemporary science. And I didn't present it here, but it was a very long research that we did. We did a Delphi three-round Delphi study in order to identify what are the essential concepts of nanotechnology that should be taught in high school level. And we used the community of experts from research and community of experts from education, and together we reached into consensus regarding 8 essential concepts, and we built upon it several programs and several evaluation of programs, existing programs, but this can be done. So I can teach you organic chemistry if you want.
I still very much embarrassed when the people when I see those structural mappings, which are extremely clumsy, which actually in the genetics people are showing and telling me that at that end is the point where the active molecule is being absorbed or attached. I don't see any logics in it. It's just a statement. So still, I believe that there is a big difference between the two, and I would think that somehow the atomic microscope and other things are fantastically nice. That probably, since I could do it at the level of the first year university student, probably one could teach it 9th grade or 10th grade students at the high school. There is no problem. It helps a lot. But to understand this sort of very complicated looking pictures, I think somehow a different way. I cannot see that it can be built up from the elementary building blocks on the atomic level. Somehow a molecular or supramolecular organization comes into the game.
Clarify, I'm not suggesting to replace, basic curriculum. Nobody will do it. This is not something I suggest. I suggest to integrate in the basic curriculum some contemporary research. You cannot do the advanced research without any background. Like Mia said, you cannot do skills without knowledge. So we need the basic knowledge, but it's not the only thing students should meet in school. Okay? It's.
Mm-hmm. And thank you, Professor Andrews. And please.
It's a long time in my mind, in more general question. What is an essential part of school curriculum which ensures understanding of all those more contemporary various steps in their education? It's every day new and new teams come away or come out, and it seems normal that school students should know something about this. But with this basic curriculum, we build the skills and knowledge to understand all this new contemporary science. And what are the basic physics and chemistry curricula teams which ensure that? I don't know whether somebody is researching this part of.
Mm-hmm. Wow, it's a really good question. For example, I can tell you that in Israel, we deleted the organic chemistry from school chemistry. We said, okay, so we had it used to be part of the curriculum, and the chemistry committee decided to delete it because they said, okay, you cannot put everything, and maybe this very complicated names and like you said, maybe we don't need it in high school. If someone will want to be a chemist, they can do it in the university. So I think we should reconsider the curriculum from time to time and don't take as granted that what we have in the introductory book should be part of the school curriculum, because world is changing, students are changing, and what we need is changing. So, for example, I don't know, I can think about stoichiometry. Why should we learn? Nobody uses it today. Everything is computerized. So I think we should think about it. Doubt the thing that seems to be really. Mm-hmm. Yes, for example, geometry is a very good way to work on reasoning. So maybe we don't really, it's not important to know, but it gives a student a way to practice reasoning and argumentation, why these two triangles are similar. So this is a skill maybe. Yes.
Okay, Ron, thank you very much. We need to finish. Sorry, if there are more questions, Ron is here, we are here, so please approach her. It's an interesting talk. It raises a lot of questions, more than answers sometimes, and I'm sure that many people would like to ask more questions, so Ron is here and you can catch her afterward. Thank you very much, Ron.
So now it's time to move towards panel discussion, and we need to do some arrangements for that. So let's have break 7 minutes and then come back. And Mario, your question can be asked from Ron during the panel. I saw that you wanted to ask. So 7 minutes and then we continue.
Can we have a slide? Yeah. Excellent. So, good late afternoon, everybody. It's great to have you here back. And also the people who are looking the video, it's nice you are still following the meeting. And we have a panel, and there are two topics in the panel. So what kind of competencies are needed in careers, in private sector and industry. And of course now we are discussing from the STEM, science, technology, engineering, math point of view. And then another question about expectation of the input from school science education. So what school science can do in order to support the learning of those competencies. And in our panel already Professor Andras Baktos have been introduced, so I will not introduce you once again. But we have Helin Sembrilaski, and he has been working as a teacher for 6 years and defended just recently, a couple of months ago, and now she's continuing as a postdoc. So we have a teacher view and postdoc view in our panel. And then we have Dr. Katrin Vaino. She defended some 10 years ago in science education, so both Helin and Katri are from the group of MIA. And she worked then a short time in Helsinki as a postdoc, but also in Sweden in Umeå, and now back again in Tartu University as a researcher. And then we have Professor Ron Blonder, already introduced, so we are almost ready. Maybe I should introduce myself. I'm working as a professor of science education at the University of Helsinki. So I have 3 questions. They are coming to the screen, and we agreed that about 3 minutes everybody can maximum use for answering the questions. I think that almost all the issues have been discussed. I was thinking that we are answering in the panel, so maybe it's more like summarizing issues. So what are these high-level experts in our panel, how they are summarizing what we have learned today? So my first simple question is that what kind of competencies teachers should emphasize in science education? And from the point of view that they are really needed in labor markets. So should we go in somehow an order? Maybe we start with Ron and please, can you summarize?
Okay. So thank you for this really good question. I think this is a $1 million question, this is we say. When I look at the students in school and I imagine them as adults, and I think what I would like to see when they graduate the school system. And when I look around what happens in the media and in the streets in Israel and all around the world, I would like to see our graduates able to see the data, available data, to analyze it, and to reach into conclusions and to build their opinion upon this. Instead of saying, I don't believe in climate change, or I believe in climate, I don't, this is, or even I believe in climate change. I would like to see, these are the data. We see the data regarding the carbon emissions, and when I analyze the data, I realize that there is an increase of carbon dioxide in the atmosphere, and I realize that we should reduce the use of fossil oils. And this is an example. I would like to see our graduates be able to argue with other claims using authentic data that they analyze and reach into conclusions. And this is not against, but this is in contrary to what we see in the media and in the newspapers, that people really believe in something and fight for it, but they don't even check what is the resource for this opinion. And later in the panel, I will also talk about student agency, because when you have a well-based opinion that is based on data that you analyzed, you can also develop your agency to change the situation and to act upon the results that you found. And this agency, students or adults or citizens with agency, this is something that I would like to see in the future of our globus. Do I still have time?
Thank you. So,
No.
Katrin, please.
First, I would like to intrigue a bit, and for me at least, the idea that general education and labor market are in the same sentence sounds a bit too neoliberal, but there is no wrong answers, questions. There could be wrong answers maybe. So it can be questioned. But in terms of general education, I'm not talking about vocational education or higher education. We could rather start asking, what is the world? It somehow reflects what you already have said. What is the world we'd like to live in the future, in the near future, in the a bit more far future? Then what could be the society that we would like to live in? We could start from societal needs, the needs of our planet, thinking about our planet, what it needs, and then what individuals in this society could need, like very, very basics, like, I don't know, physiological needs, psychological needs, need for self-actualization, and then having this kind of imagination in our heads to think what could the competencies that could feed this picture, this future picture. And I won't talk about specific competencies, because I know Helen will talk about, but if you take this competence as a whole, any competence, then there are knowledge, skills, and values. And there is one aspect that is definitely too less emphasized. It is values, beliefs, let's say intellectual virtues even, like open-mindedness. It was said by Marianne before, open-mindedness, curiosity, honesty, even intellectual humility, that I am skeptical towards my own data, I'm skeptical towards the other data, or let's say claims. So, and this has gained too less emphasis in our schools as a goal. No problem. There are only few people who actually deny that it is important. But the problems start when we start to operationalize the idea, the very general idea. What could be the instructional design that would develop those values and the very needed values and attitudes? And even more important, how we will assess those values. Because without those, let's say, I am proud to say right values, because it's really complicated what is right and what is wrong. But without right values, the knowledge, science knowledge, could be like weapons in the hands of science denials or I don't know, conspiracy theorists, or somebody who is selling crap and talking that, oh, this cures like everything. So, and the only kind of weak link has been that teachers have implicitly in mind that I need to develop values, the right values, but how to do that? And my message, the kind of positive message would be that we could use affective domain. Krathwohl is a well-known name, but there are others. Also, there is Kohlberg theory of moral reasoning that could be used for building a taxonomy of learning outcomes. And I can say that we have made a small step in our science curricula which is not actually accepted by government. We are waiting and waiting it, and by our science teachers, national science teachers, like a small step to define learning outcomes that can be assessed formatively, summatively. So,
thank you, Katrin. And Helene, your answer?
Yes, thank you for your really good answers. I tried not to repeat you, but in my case, I wanted to emphasize the need of people who need to identify different kinds of problems. Also, they need to know how to solve the emerged problems too, and not only to do it on the paper, but to do it in real life situations too. And I really enjoyed the scheme that Mia presented too about the transdisciplinary skills. I think that these should be emphasized at the school. And what else? I think what helps to, for example, emphasize the skills, more hands-on activities during the lessons, then to think more about real-life situations where they can use their set of skills that they have developed during science teaching. And in my experience at the school where I taught, for example, there were a lot of gifted students. And I think that Marianne, in her presentation, outlined the optional learning materials or the moments as well. And I think that the students should have some possibilities to make different kind of options throughout their studying. Also, what is important are the self-management skills. Especially COVID-19 pandemic raised them. Also, right now, it's important to develop these skills throughout the teaching. I like that, Katrin, you finished with assessment that should help teaching too, and needs to help learning. And this should be overlooked too, how to assess other skills, not only how to apply knowledge.
Okay, Andreas, what do you like to?
Okay, I am a technician. I have not much sense to this general setup of different skills. Model building. Finding out what are the important data. More and more data we are getting from different sources, and one should be able to find what are the relevant ones, what are behind the dynamics of a firestorm or of a disease epidemic. If you are not able to find those variables, data, which are driving the whole, and then you build, if you find it, a model on it, and then you just compare the outcome from the model with the reality. If you don't have this sort of way of thinking, then you are lost in the mass of the data, and I am sorry to say that fortunately for mathematicians and physicists, they somehow get accustomed to this reductionist approach to the phenomena. They are over-reducing many times, so one should be very critical against these fundamental sciences, but you should appreciate that this is their specialty. And actually, although I don't know whether this is the right place to say, but the entrepreneurs like very much this capability of our students, and I believe that also the wider public should somehow understand that not everything is able to influence the same way a phenomenon, but there are really driving variables, and that we can start to teach in very elementary level already in the school. What I was thinking, just to give a concrete example, there was a big revolution in science when Newton understood that the relevant quantity is acceleration. While until then, you know probably well, everybody was speaking about velocity. So that is just the simplest example to show how important is it to recognize relevance in some part of the data and dependence determined by other variables in a large other part. That's what I can contribute.
Thank you. So in a summary, so those scientific practices, finding out, modeling, checking what is true, what is not true, it looks important to learn at school. And also those attitudes and like agency, I think this belongs to the attitudes who have to have that kind of things, transdisciplinary skills mentioned. But what was interesting, Katrin raised these values we have not emphasized so much. So in German language there is this Bildung idea, so we are not educating young people to the labor market, but for life. And that was really, really important view we were missing here in our discussion. And we are maybe, at least I am too much neoliberal type of thinker, so that was good to raise. And when I was preparing myself to this panel, I was looking the UNESCO Universal Learning description of the competencies people need for good life. I think that is quite close to the values, and those OECD models and European Union lifelong learning or key competencies, they are more neoliberal type of descriptions. I have been a little bit wondering, nobody has not mentioned so directly those OECD and European Union models, but I think combining with UNESCO model, I think we can find combining this, your answers and those we are more clever. So I skip this OECD model and we have been discussing about challenges we are meeting in science education, and we are quite easily saying that science is not interesting for our students in the classrooms, and they are not orienting to the science and engineering careers. I take a look for some PISA data. I will show you. I hope that you can also see, but it's behind you. It's a little bit challenging, but you can see here. So what is the situation in 16 years old young people mind? What they think, how willing they are see themselves in the field of science, math, engineering, when they are 30 years old. So unfortunately Israel is missing because I take only the upper side of the scale, those OECD member states, sorry for that, but we can see that in Finland we are having really challenge. Only 17% of the young people are looking. It's very similar in Hungary. But in Estonia, 25%, it's not so bad. So we should remember that situation in some countries is not so bad. Then I have only Finnish and Estonian data. So in the PISA questionnaire, there is a question that I enjoy acquiring new knowledge in science. And this is the percentage of students who agree or strongly agree. In Estonia, 80% of the young people think they are really willing to acquire new knowledge. Finland is much, much lower than OECD average. I'm happy working on science topics. In Estonia, students are more happy than in Finland. And what is more dangerous is the trend. So in Hungary and Finland, this opinion is going down. So it's coming even more worse. But in Israel and Estonia, the students have made progress. So in the PISA results, the Estonia is nowadays the model for the whole world. And we can see that in science and math, the green line, the Estonia has made progress in the competence. Finland is going down in science and math, so that might be the real serious problem. The topic we have not discussed is the gender balance. How many females are orienting to the science careers and how many males? And actually, in Estonia, in natural sciences and math, 80% of the students who are graduating master level, they are females. In engineering, it's only 20. In Finland, it's 60, and Hungary it is 50. So this gender balance is not yet discussed. Okay, we might be happy in Estonia, in Finland, that there are quite nice number of females, not in engineering, there we have, and in computer science. But then if we look for how the career develops, so in master level there are more females, but when we go to the full professors, this data is actually from Sweden. I was not able to find from Finland. So, but I think the similar situation is in Estonia and Sweden. So this gender balance is not good if we are looking for associate and full professors. And in Nobel Prize winners, it's even worse. Okay, I give you some data. And now I ask you that you can take only one. What is the most serious challenge we have? But you have to tell me also how to overcome it. You take one of those I show you and how to overcome. So maybe we start from the Andras now and come this direction. Please.
For me. Maybe I stay with the women participation in science, because there I have a little bit more information. So the situation is quite interesting. The attraction of astronomy and is quite high, exerted on women. Solid state physics and more, how to say it, more Earth-based sciences not so attractive. So we should be able to understand, and probably it has some sort of psychological background, why this distinction is there. This is one which I can contribute. The other thing, what can we do against of this inequilibrated participation? In Hungary, what we observe, that is something which we inherited from the Soviet system of assessment. This is the Doctor of Science degree. Among the Doctor of Sciences, the number of women scientists is increasing. So definitely it's an interesting tendency that now they stay longer and longer. Behind could be that they have an advantage given. So, you know, there are some sort of indicators, publications, citations, and so on. Now, somehow the Akadeemia of Sciences has arrived to take into account the mother's years in case of the woman, because they have to stay home after the birth of their children. So I have also a collaborator who somewhat later go to this Doctor of Science degree, but the Academy gives some sort of, takes into account it. And there are a similar thing. Also, we have application schemes, stipend schemes for forming your own research group. Now, for women, those which I mentioned, those circumstances, no positively are taken into account. For forming a young researcher group, a woman can do it at age 38 or 40 even, because they take into account the maternity. I think I agree with this. Let me just make my position. And the last thing is, however, that the number of the among the number of the members of the Academy of Sciences in Hungary, it is still a problem. So against the fact that the number of the Doctor of Science, which is a sort of precondition to get a nomination for being elected, still academicians are elected by academicians. And that makes a potential barrier, because most of the academicians are men, and somehow this is a bad positive recoupling. So here there are big discussions within the academy, but still an explicit measure favoring, okay, I can even tell you, there is one decision that if in a competitive sort of election scheme, a woman candidate passes the 50% level, although in the ranking she might be the fourth, then the president of the Academy of Sciences has a quota, a very small quota, 3-4 places. And okay, he decides. He should not tell on which. During the last election this spring, actually he used, I think, 2 places to give them. So that is a challenge which, as an elder scientist, I participate in the discussion, and I see that the challenge is there. People are taking seriously, but to move away from this sort of machoist organization of science takes long time.
Okay, thank you, Andras, for taking this gender balance. And it is not only in those positions, but we need role models, because role models are influencing very much young people thinking. And if there is only one gender type of role models in kind of high-level positions, so this is a serious issue, actually. But Helen, what is your challenge you are solving now?
I didn't focus on the gender issues, but more on something else, yes.
Yeah, please.
On there is lack of people who take as their career opportunity to go on the STEM field and to choose the career from there. And I think the problem is more raised by that, how they have been taught at the school too. For example, if it's not motivating, then it can cause the dislike to choose it as a career option later on. And also, if to compare science subject at school with other subjects, then the content is more heavy, and it is abstract in more science fields, more abstract, but that can cause it, the lack to choose it. And also in science education, there is need of supportive assessments too, that can show to the students
that they have enough of skills and knowledge to choose the STEM-related career, that they don't feel that they didn't take the test well and they are not good enough to take that career option. I think this is something that can be changed, and also it is something that we can address more, and I can address it.
Yeah. So the cost young people have to pay is very high. And Katri, what is the challenge you saw?
I picked up young people's willingness to take up STEM studies.
STEM studies, and
Yeah.
what is the solution?
And what is the solution? So I think, and I believe in it very much, that first of all, we have to strengthen young people science identities. Okay, this is just empty words if there is no kind of agenda behind, but we could do that through simply meeting their psychological needs, three psychological needs: need for competence, need for belongingness, need for autonomy. And the thing that you just said, that they feel in science lessons as kind of inferior because they don't get it, they just don't get it. This is the crucial aspect, how to build scaffolding to students during science lessons. So this has to be part of science teachers' basic schooling or in-service schooling. So this is one aspect. The other aspect is that the meeting, I am of course talking about self-determination theory and their kind of postulates, but which has empirically proven. So this meeting their needs is not only important for raising their motivation and building their identities, that they feel that science is something, even for me, let's say, but this is also important for internalization of those values that I just said. There is research behind, but the values or kind of expected beliefs need to be modeled. As it was just said, they need role models. In case it is not modeled, but in whatever format, probably they won't develop that kind of values if there is no family kind of effort behind. And if I may, to make a comment with respect to gender aspect, this is already the other one. No. Okay, I will do that afterwards.
Thank you.
Yeah.
So also quite psychologically oriented analysis, but also the sociological orientation in these role models and gender. And Ron, what you pick?
Okay, so I would like to return to the ideas that I said in the first round about how I imagine the graduate of the educational system, people who know how to base their opinion on data that is validated and they can analyze it. And I think that if we would like to raise people like this with these skills, we should, in order to emphasize these skills, we should change not only the curriculum that will teach them how to do that, but we should also change the whole system. Because if we want that teachers will really do it, this should be also emphasized in the assessment, because teachers eventually teach for the test, because at the end of the school years, the students have to take the external assessment, the matriculation exam in Israel, for example, and teachers are responsible for the success of their students. So if we appreciate and evaluate certain skills like argumentation, database argumentation, this should be part of the external exam. This should be part of the curriculum. This should be part of the teaching. So only when we will conduct a systematically change, we will be able to see different at the end of this process. And I would like to connect it to something that I saw in Poland. A year ago, I visited there the educational system, and they wanted to improve their results in the PISA test. So they changed the assessment, the national assessment toward the PISA test, namely reasoning, and based their opinion on analyzing the data and base their opinion on the data. And very fast, they really improved their results in the international PISA test. It means that when you want to do a change, you should look at the whole picture, change the assessment, change the curriculum, and change the teaching.
Yes, assessment is driving the system. In Finland, we changed the matriculation examination computer-based, and now every student in upper secondary school is using all the time computers in learning. Maybe it's not good, but that was a political. So you can change assessment and you change the system. Okay, we have almost used our time, but Mia gave us some extra time, and actually my last question is not necessary to answer in order, so those who are most willing, they can start, and let's have a look if we have time for everybody. But anyway, actually, Katrin and Helene start my last topic somehow. So we have not discussed today so much about the kind of research frameworks for making research on what makes science more attractive, what makes science careers and studies more attractive. And of course there are many frameworks, and quite commonly used are those sociologically oriented, and Katrin mentioned about those role models and gender, maybe they belong to that type of orientations. And then Katrin mentioned also those self-determination theory issues, the competence and autonomy and relatedness, and Helen mentioned this expectance value theory related issues related to the cost. The cost is too high. So if we are now starting our serious research on the topics we have been discussing today, so what to pick as a framework? So I have a couple of ideas in those sociologically oriented frameworks. So the role models are important, and how the young people perceive the prestige and the work conditions, and it is also known that it's quite young people, 9, 13 years old, develop kind of attitude to the career and the role of families. We have not discussed about families here. That is important. And then Mia and me, we participate to the Rose study, and as a part of the Rose study, we become familiar that how the social position of scientists and engineering have been weakening, and lifestyle. Somebody mentioned about the hard life, and it's not so attractive, low status relation to the workload. So that kind of issues belongs to the sociologically oriented. And for example, Jackie Eccles have made research on starting from the more psychologically oriented theories, and this is kind of big picture, but maybe we can take only these main ideas in the expectance value theory. So the intrinsic value, enjoyment of liking, and utility value, attainment value, and cost. So what do you recommend as a panelist for how to orient to this type of research seriously, starting from more sociologically oriented or more psychologically oriented? So who's willing to start? I ask, who's willing to start?
I can try.
Okay, Ron, please,
Okay.
please start.
I think one issue related to science learning is the thinking of some of the students and the teachers that you can understand science or not. It's either you have it or not. And I'm more trying to target regarding more a growing mindset. It's not that someone is born to understand science and mathematics and someone doesn't. If you try hard enough and if you persist and try again, you will be able to learn. And I think when teachers and students realize this or adapt this approach of growing mindset, things will look differently. Because if there is a question in geometry, for example, at the first time I will not be able to solve it, and then I will look at it again, and then I will try again. And every time I try to solve a problem, I improve my understanding and my knowledge. And this is how it works in the real world. It's not that people go to a problem and solve it because they are genius. They look at the problem, they examine it, they talk with others about the problem, and then slowly, slowly they reveal parts and aspects that they didn't see in the first time. Maybe they think that the problem should be defined differently, and then they try to solve it. And I think that the growing mindset is really something that is very important in science and mathematics in school. And it also reflects how science is really done in actually labs. Because if we look at real problems that scientists solved, it was never at the first trial. What you solve very easily, it's not really interesting most of the times. Things that are really a puzzle, and you have to think and to collaborate and to try different theory to approach them, these are the really interesting problems. And I think we can educate the students from a very early age not to leave the problem if they don't succeed to do it at the first time. And also to learn from the mistakes, because every time you do a mistake, you can learn from it and get better and better. And I think this is something that the educational system needs to think how to adopt this approach more deeply.
Thank you. So the mindset type of research is needed. One of my PhD students is making that type of research in upper secondary school, so I know something. So, okay, please, Katrin.
I am not that familiar with Eötvös framework, but we have been using Lent social cognitive career theory. They have both common elements. There is something that relates self-efficacy as well, and you just taught something related to that. So, and we found, it was some years ago already, we studied what factors or what aspects predict their career goals in not science, but technology and engineering. And self-efficacy was always, through different studies, it was always a kind of significant factor for both boys and for girls. But for girls, and there is also one aspect related to parental, I'm not that sure about Eötvös, but probably there is also parental expectations. And we found that for girls it was much more important than for boys. So girls kind of take account their opinion more than boys as an average. So this was kind of an interesting finding, but probably not a very unique finding, because the other studies said it too. So what kind of framework do you like to prefer? This is really difficult question. I guess it's quite complicated. I mean, this Eötvös framework, but it really comprises well the thing. If I remember correct, and if we used Lent social cognitive career theory, which is derivative from Bandura's theory, then the model described quite well their career goals. It was 60 for girls and 80 for boys even.
and in other studies it was lower. So I think this was quite a, respectable framework.
But it sounds more like a sociologically oriented.
Yes, self-efficacy, interest in...
more psychologically,
yeah.
Combining that.
But social supports and social barriers as well.
Yeah.
It was kind of combination of...
I will support your ideas about the equals, and I think it's important to start from the liking and enjoyment of the learning process, that the students know how to learn, they like to learn, and based on that you can add other steps to it as well. For example, how to make the difficult parts of the career more better to enjoy even these. And yes, I think it's something that should be addressed more, the enjoyment and liking.
Kind of intrinsic values are driving human beings, so the psychologically orientation you recommend. Andras, you would like to make comment?
I am contributing the pedestrian approach.
But you already analyzed these gender issues,
yes,
and the role models, and
you think
sociologically.
you are fully right, because the idea I got is actually also relevant to the gender problem. I believe that the social status of the scientist in the past 2-3 years has increased immensely. Never before you have seen on the TV or whatever in the public so many scientists giving their lecture and giving their explanation and even trying to influence the public concerning how to behave under this epidemic situation. Only scientists could give something, although they were discussing among each other, but they had a sort of a really exceptional status in the public. So it would be very interesting sociologically, because you were referring to some older investigations, to see what happened now. And back to the gender problem. In Hungary, I have forgotten to tell you the name of Katalin Karikó, who will give an immense push to the interest of younger girls towards scientific professions. So the importance of the personality, of the individual achievement is extremely, the influence of the individual achievement is extremely high, and since the personality of Karikó is quite direct, quite friendly, I believe that she had quite positive influence on the choice of the young girls towards scientific careers.
Thank you. So Mia gave this 10 minutes extra time. There is 2 minutes left. So if there is an audience, somebody would... Okay, Rahel, please. Microphone, please.
What I mean, the gender, I just would like to add, it's now a problem which, occupies a lot of people. There was a global survey about the case of gender, and there were there are quite a lot of projects now trying to encourage women in this issue, and one of the conclusions, I don't want to take all the time, was that, as Ron said about something else, it needs a systemic, change. It should come from the policymakers down. And it's not a matter of women, it's a matter of society. It's a matter of family. It's something that has to bother everyone, because you have so many talented PhD students who finish with a very, very high scores, and afterwards it drops. So it means something. So you need to be a superwoman sometimes in order to succeed with your children, family, but again, policymakers need to understand it, and husbands, families, and everyone. So this is part of what is now encouraged to do in Israel and with forums and everywhere in the world.
Okay, I would like to thank you for the panel. You were following the schedule and you were giving good answers. I'm sure that the audience benefit of your analysis. And now we are coming to the next phase, and so you can leave your position and go to the audience back. So thank you.
Thank you.
Thank you. And Mia, you will start.
Yeah. So we have now 20 minutes for concluding remarks, no more. And I invite here Rachel and Jari. And why those? Because concluding remarks are linked with SciCar project philosophy and attempt to achieve something. So Rachel is representing Weizmann Institute, which is partner for SciCar to stress the role of science and to bring in science component so that how scientists work together with educationalists. So science comes first from that institution. And Jari is from University of Helsinki, and Helsinki brings in education component. So education working with science. So the educational component competencies come strictly from Jari's talk. And myself, I represent University of Tartu. So the benefiting party, because it's twinning project where two other universities are actually collaborating with a third in order to create some new knowledge, some new competencies. So here you all are, who are from Estonia. We all have gained a year ago and this year new competencies, new knowledge, and there is still a year and a half to go to do more. But let's move now towards the concluding remarks, and maybe Rachel, you start with emphasis to science, and Jari, and if there is anything else to say, then I will. So please.
Sit here, no? Mia, don't you want to sit here? No. Oh, okay.
Why to sit? I'm sitting the whole day. Stand.
Mia. Okay, so first of all, again, thank you, Mia, for organizing this very useful and contributing symposium, which I find it raises even more questions than answers. It gives more opportunities to questions to ask. So I will start with what we had here and recommend also what we should continue next year and then we'll have others. So what we see that over the years, based on research in education in general and on science teaching and learning in particular, we learned a lot about issues related to teaching and learning, on students' behavior and interactions in the classroom, the effectiveness of ICT, and methods enhancing the effectiveness of learning. However, we need always to ask ourselves, what is the impact of all this? We're doing it year after year. For me, it's many, many years that I'm doing it. I don't like to mention it. And what impact do we make? Are we in alignment with changes in culture, with changes in the world, in the politics, with the climate change, which influences everyone, with technological developments? We should always think about it. We can't teach or think as we did 20 years ago, although I liked it to teach like that, but these are not the same students and it's not the same circumstances. So this seminar referred to the importance of getting evidence of the impact of science education in attracting young people towards science studies and science-related careers. The evidence of impact may be achieved by bridging the gap between research in science education and practice. That will also help in creating a network between science education research and science education, or studying, for example, criteria for equality in practice-oriented research in science education, equality in inclusiveness, diversity, being very much attendant and very much sensitive to all these parameters. Now, the criteria should take into account students' cognitive, the families which were here mentioned, his cultural components, motivational, personal, affective aspects, teacher needs and beliefs, different types of curricular material, and so on and so forth. We had this beautiful panel, which I liked a lot. It was only short for me, in which we had to think about the motivational patterns or how to prepare our students to future happenings or disasters or survival, and about research at the universities and so on. So in order to address the topics which were discussed in the seminar were related to research which is integrated, embedded into science education, in teaching and learning, in relevant curriculum materials. We always have a research before, we try it out, then we get our evidence, and then we change again. All the reforms are based on what's happening first of all, and then we need to have a reform. Impact of contemporary relevant curriculum materials, impact of contemporary issues in science education on student motivation, contemporary issues such, again, we are sticking to what was talked here, sustainability issues or climate change issues, and so on. And while there was also the panel discussion, which was held about the competencies which are essential for a career in the private sector and in industry, competencies such as networking or how to, one of the most contemporary research, global research, and so on. Again, I mentioned the climate change once again because I wanted to show, but also about gender issues, about the STEM education, which we have. The gender issue was not discussed, but it's very self-evident that you can't discuss everything unless you want to make it very, very, very superficial. So maybe gender will be next time discussed, and so on. So, in summary, the seminar managed to accomplish its goals, to my opinion, namely focusing on issues referring to integrating research with teaching, competencies needed for teachers in order to address the effectiveness of learning, to see how the impact is done, improving the quality of science education within international networks, and somehow brainstorming about what is needed today actually in science education. It was not finished, but it was a start for it. Now, one thing that I feel we should also discuss, it's about the systemic change which is needed to be done, systemic from up, down. We can't talk only about one thing, about values versus political issues which are needed. And as I mentioned before, the gender, but this is the whole project. And just I want one thing to mention. When Ron talked about being the mindset and changing mindset, I recall the movie. It should maybe be not presented, how do you say, a movie shown to students. It was Karate Kid. How do you prepare, I finish, how do you prepare your students to be strong and to believe into the same, to have the self-efficacy, to change their mind, and to believe that they can do it from very simple exercises. So thank you very much.
So thank you, Rachel, for quite extensive conclusions. And Jari, I don't give you more time, because try to finish by 4:30. Then I have 1 minute to say.
1 minute. Okay, I have 7 minutes. So first of all, of course, thank you, Mia, for organizing this meeting and giving us possibility to discuss. I would like to recall what the head of the education committee at the Estonian Academy of Sciences, Jakob Kübarsepp, recognized in his talk those 4 challenges. So I will shortly mention the 2 challenges and answers I have found in this meeting. So the first challenge, he mentioned that how to attract young people to STEM field. So Professor Patkos gave quite many answers actually in his presentation, and I pick one, the authenticity. So how to make science education, math education, engineering education more authentic from the point of view of students and science. So there were examples, for example, from the geography, how the geography activities were very much changed in the project, and they were very much competence-based, solving real-life problems and that kind. So it was coming more authentic. So also those Arnold systems and what the engineering and scientists are doing, that was transferred to the high school, upper secondary school physics classrooms. And you mentioned also the inquiry-based chemistry education, how to make chemistry education in a way that it is following the similar, epistemologically similar processes than in real science. But in a similar way, Professor Blonder make this authenticity also quite nicely in her talk. He talk about those outer activities, informal activities, conference type of activities. So I think that is one key we have to look more, how to make the science education, math more authentic from the point of science. That was the message I quite clearly pick. But also the Marianne's presentation about these climate competencies. So why we are not thinking enough about the real competencies are needed in real life? So why we are not following our science curriculum this kind of knowledge that is acquired from real professionals? The second topic, this is very shortly, the STEM teachers, how to educate high-quality STEM teachers and how to attract enough STEM teachers to our programs. So Professor Patkos and Professor Blonder analyzed those competencies. What kind of knowledge or competencies the STEM teachers need? And of course you mentioned the content, subject matter knowledge is important for STEM teachers. And Patkos talked about this content pedagogy and Ron about pedagogical content knowledge, and they are quite close actually. But what was interesting for me, they were coming something out of the box, so out of the Schulman's box. So this teacher as scientist way of thinking. So the kind of teachers as researchers, the identity of the researcher, they are able to make changes in their own classroom and do something what they have never done earlier. And also the transformative agency, kind of innovative orientation in teacher profession. Schulman never mentioned about that. and this contemporary knowledge that is needed in teacher profession, and combining this informal, formal situation. What was not so much analyzed, I think, the role of STEM teachers as career counselors, how a STEM teacher in his classroom can also raise those role models in science and engineering, math. That is something I think we should discuss more. Maybe what Rahel mentioned, this systemic change, I think that's I would like also to emphasize. But I skip this analysis of the Kupersep analysis about the attraction of doctoral students and academic careers more attractive. Maybe I can have the possibility to come back to those topics. So thank you.
So thank you, Jari. So I think that we have concluded everything what has been spoken here. And even if I wished, I don't have much else to say. But yeah, yes, I want to thank you, everybody who has come here. Once again, big thanks to the Academy of Science staff, hosting us, helping us. So thank you for staff who was filming, taking pictures. So making this attractive and very, very, very much updated for the 21st century. And my biggest thanks go to the young scholars who have come here, and some of them might have the first time the chance to speak here in such a nice hall. And I promise that when we come here, once again, then more young people will be amongst the speakers. And thanks. And as we live in an age where we shouldn't waste anything, then I still think that there is some food but shouldn't stay when you have left. So please come and help together to finish some coffee and some sandwiches, which is in the other room. So thanks for coming.
you.